Right now, you're hurtling through the cosmos at an almost unbelievable speed. You don't feel it, you can't see it, but your entire existence is a frantic, silent rush through the dark. Earth spins, and it orbits the sun. The sun, in turn, orbits the center of our galaxy, the Milky Way. And the Milky Way itself? It's rocketing through space at a staggering 600 kilometers per second. That's over 3 million miles per hour. You are on a cosmic bullet, aimed at a destination you've never even heard of. Welcome to the Science for Deep Sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. When we look up at the night sky, we're greeted by a beautiful illusion. We see a canvas littered with stars, a dense tapestry of light that suggests a universe teeming with neighbors. We think of space as being full of stuff, but that's not the whole story. It's a profound misinterpretation of the view from our tiny, privileged shoreline. The truth is far more staggering, far more humbling. The universe is mostly nothing. That gorgeous scattering of stars is a comforting lie, concealing a reality of emptiness so vast it fundamentally challenges our ability to comprehend scale. The true stars of the cosmic show aren't the galaxies, but the unimaginable voids that separate them. These aren't just gaps, they are oceans of near-perfect vacuum stretching for hundreds of millions of light years, regions so empty they make the space between stars feel crowded. On this journey, we're not just going to visit the stars. We are going to venture into the real heart of the universe, the mind-bending emptiness that lies between the great galactic islands. Prepare to have your perspective of everything shattered. Leaving our cradle, the solar system, our journey into the great nothing has to begin somewhere familiar. It has to start here, at home, so we can build a ladder of scale, rung by rung, until we're staring into the abyss. Our home is Earth, a sphere of rock and water just under 13,000 kilometers in diameter. This is a scale we can actually wrap our heads around. We can walk it, fly over it, measure it. It feels big, but in the grand scheme of things, it's less than a single grain of sand on all the beaches of the world. Let's start zooming out. Our first stop is the Moon, our constant companion, about 384,000 kilometers away. The Apollo astronauts, in the fastest crewed vehicles ever made, took 3 days to cross that gap. It's a distance we've conquered. In the language of light, it's just over 1 light second away. This will become a very important unit of measure. Now, let's push further. Mars, the red planet, orbits at an average distance of about 225 million kilometers from us. Light itself, the fastest thing in the universe, takes about 12.5 minutes to make that trip. Think about that for a second. When you see an image from a Mars rover, you are looking at the past. The gap is already becoming a gulf of empty space where very, very little exists. But we're just getting started. Let's accelerate past the asteroid belt, a region of rubble that's surprisingly empty itself, and head for the gas giants. Jupiter is about 778 million kilometers from the Sun. Light takes over 43 minutes to travel that distance. Saturn, with its majestic rings, is nearly twice as far, at 4 billion kilometers. The distances are becoming so huge that using kilometers feels absurd, like measuring continents in millimeters. This is why astronomers created the astronomical unit, or O. 1 astronomical unit is the average distance from the Earth to the Sun, about 150 million kilometers. Using this ruler, Jupiter is about 5.2 astronomical units from the Sun, and Saturn is at 9.5 astronomical units. It tidies up the numbers, but it masks the true, desolate emptiness we're traversing. Let's push to the very edge of the classical solar system. Neptune, orbiting at 30 astronomical units, or 4.5 billion kilometers. Light from the sun takes over 4 hours to reach this icy, blue world. This is the edge of our familiar planetary family, but it's nowhere near the edge of our solar system. To find that, we have to travel much, much further, to a boundary called the heliopause. This is the edge of the bubble blown by our sun's solar wind. Outside this bubble is the true beginning of the space between the stars. Humanity's farthest flung emissaries, the Voyager 1 and 2 spacecraft, have crossed this boundary. Launched in 1977, it took Voyager 1 35 years until 2012 to finally punch through at a distance of about 121 astronomical units. A journey of a lifetime just to leave our sun's immediate neighborhood. These probes, traveling at tens of thousands of miles per hour, have barely left our front porch. This is our first real glimpse of the scale we're dealing with, and ahead of us lies the first of the great voids on our journey, the space between the stars. The interstellar void, lost in the Milky Way. Having crossed the heliopause, we are now officially in interstellar space. Out here, the environment is an incredibly thin soup of individual atoms, mostly hydrogen and helium, called the interstellar medium. It's a vacuum more perfect than anything we can create in a lab on Earth. Our journey, however, still hasn't reached the true edge of the solar system. Beyond the heliopause lies a theoretical, immense shell of icy bodies called the Oort cloud. We've never seen it, but its outer edge could extend to 100,000 or more. At that distance, you are already about a quarter of the way to the next star system. Light itself takes over 1.8 years to cross this ghostly sphere of our own solar system. This is where the astronomical unit breaks down. We need a new yardstick, the light year. It's the distance light travels in 1 year, a staggering 9.5 trillion kilometers. It's a measure of distance, not time, and it's the only sensible way to talk about the gulfs that await us. Our nearest stellar neighbor is Proxima Centauri, 24 light-years away. That sounds deceptively close, but it's a chasm of 40 trillion kilometers. If our fastest probe, Voyager 1, were aimed at it, the journey would take roughly 75,000 years. 100 lifetimes of human civilization, back to back, just to reach the very next star. Let's try an analogy. If the sun were a grapefruit, Earth would be a grain of sand orbiting 15 meters away. And Proxima Centauri, the next grapefruit-sized star? It would be over 4,000 kilometers away. Between those two grapefruits is a vast, desolate emptiness. This is the interstellar void, and this is the norm. Our galaxy, the Milky Way, is a sprawling city of stars, containing an estimated 100 to 400 billion of them. But it's a city built on an impossible scale. We usually say it's about 100,000 light-years across, but recent studies show the luminous disk of stars is closer to 120,000 light-years, and the entire dark matter halo may stretch almost 2 million light-years in diameter. Let's travel across it. Even in the relatively dense spiral arms, the average distance between stars is about 5 light-years. It's like a desert where each grain of sand is separated by miles of empty space. As we move 27,000 light-years toward the galactic core, the star field becomes spectacular, culminating in a supermassive black hole with the mass of 4 million suns. But our journey is outward. We turn around and travel 73,000 light-years to the far edge of the galactic disk. Now, we stop and look back. Our home galaxy hangs in the blackness, a magnificent, swirling pinwheel of light. It feels immense, a universe unto itself. But on the journey we're about to take, this entire city, this colossal structure, will shrink until it's just another speck of light. We are about to take the Great Leap into the intergalactic chasm. The Great Leap. The intergalactic chasm. As we push away from the Milky Way, our home galaxy shrinks. A majestic swirl, then a fuzzy patch of light, and finally, just another star in a sea of black. We are now truly adrift in the ocean of the cosmos. Welcome to intergalactic space. The emptiness here is a whole new level. The intergalactic medium, IgM, has a density of maybe 1 hydrogen atom per cubic meter. But it isn't uniform. Scientists believe it's organized into a vast cosmic web, a filamentary structure connecting galaxies. We're traveling through an almost imperceptibly thin, superheated plasma. Let's set a destination, the Andromeda Galaxy. It's the most distant object you can see with the naked eye, a faint, fuzzy smudge in the night sky. That smudge is 2.5 million light-years away. Let that number sink in. Our galaxy's visible disk is about 100,120,000 light-years across. The gap to our nearest major neighbor is about 25 times larger than our entire galaxy. And here's a fact that needs updating. We used to call Andromeda our slightly larger twin. It turns out, it's more like our big brother. While estimates have varied, recent data suggests Andromeda's visible disk is a colossal 220,000 light-years in diameter, making it nearly twice the size of the Milky Way. To picture this, if our Milky Way were a dinner plate, the Andromeda dinner plate would be over 7.5 meters, or about 25 feet, away. Everything in between is almost complete and total emptiness. As we make this journey, a strange thing is happening. Andromeda is moving towards us at about 110 kilometers per second. In about 4.5 billion years, our two galaxies will collide and merge into one giant elliptical galaxy. This is possible because we are part of a small cluster called the Local Group, an island of about a dozen galaxies bound together by gravity, spanning roughly 10 million light-years. Within this island, gravity still wins. But as we're about to see, once we leave our local group, the fundamental nature of the universe takes over. And that nature is one of expansion and ever-increasing emptiness. The great nothingness, exploring the voids. Leaving our local group, we need a new sense of geography. Individual galaxies are houses, galaxy groups are villages, and these villages are part of much larger structures. Our local group is on the outskirts of the Virgo supercluster, which itself is just one appendage of an even more gargantuan structure, the Laniakea supercluster. Stretching 520 million light-years across, this is our true cosmic home. At the heart of Laniakea lies the Great Attractor, a gravitational anomaly pulling our entire galaxy and thousands of others towards it at over 1 million miles per hour. But we'll never reach it. The dark energy that expands the universe is stronger than the gravity holding Laniakea together. The entire structure is being stretched and pulled apart. And this brings us to the most shocking feature of the cosmos. The universe is a cosmic web. This web is made of vast, interconnected filaments of galaxies. Where these filaments intersect, you find massive galaxy clusters. All the light, all the life, exists along these threads. But what about the space between the threads? Between the filaments lie the cosmic voids. These are unimaginably vast, roughly spherical regions with very few, or in some cases, almost no galaxies. They make up the overwhelming majority of the universe's volume, as much as 80 to 90%. The universe isn't a web of galaxies, it's a collection of colossal bubbles of nothing, and the galaxies are just the soap on their surface. Let's visit one, the Boötes Void, aka the Great Nothing. Discovered in 1981, it's about 700 million light-years from Earth with a mind-shattering diameter of about 330 million light-years. In a space this large, you'd expect thousands of galaxies. Astronomers have found only about 60. The astronomer Greg Aldering famously said, "If the Milky Way had been in the center of the Boötes Void, we wouldn't have known there were other galaxies until the 1960s. And the Boötes Void isn't the biggest. That title may belong to the KBC Void, a staggering 2 billion light-years in diameter. In a shocking twist, it appears our own Milky Way galaxy resides within this colossal supervoid. We aren't separate from the emptiness, we are part of it. In fact, new research from early 2026 suggests our local group exists within a giant cosmic sheet of matter, like a populated coastline surrounded by these immense empty oceans. These voids are the quarries from which the great cities of galaxies were built. The cosmic web and our place in it. From hundreds of millions of light years away, we can finally see the true architecture of reality, the cosmic web. It's a luminous, three-dimensional network of galaxy filaments, clusters, and the dark, empty voids in between. This entire structure grew from quantum fluctuations moments after the Big Bang, amplified by gravity over 13.8 billion years. The invisible scaffolding for it all is dark matter. But there's one final ingredient: dark energy. It's a mysterious, repulsive force woven into the fabric of spacetime itself. On the vast scales of intergalactic space, dark energy dominates gravity. It's causing the voids to expand, pushing the galaxy filaments further apart. The emptiness is actively growing. This has a profound consequence for the future. The expansion of the universe is accelerating. Galaxies not gravitationally bound to us are receding faster and faster. Eventually, they will cross a cosmic horizon and vanish from our view forever. Imagine a civilization billions of years from now, living in the merged Milkomeda galaxy. They would look out into the sky and see nothing. The other galaxies would have been pushed so far away by the expanding voids that they would be completely invisible. This civilization would conclude, as we almost did, that they are alone in the universe. The vastness of intergalactic space, supercharged by dark energy, will have effectively erased the rest of the cosmos from view. The scale of intergalactic space, therefore, isn't a static measurement. It is a dynamic, growing entity. The emptiness is winning. Our journey is complete. We've traveled from our planet, past our nearest star, across our galaxy, and stared into the billion light-year emptiness of the cosmic voids. We have reached the edge of comprehension. Now, let's zoom back in. Past the cosmic web, the superclusters, the voids. Back into our local group, to the single bright swirl of the Milky Way. We dive into its spiral arms, past billions of stars, back to our tiny, yellow sun. We fly past Jupiter, Mars, and finally, we see a tiny blue marble, suspended in the darkness. Home. After witnessing the sheer, overwhelming emptiness that makes up our universe, this single, fragile point of light becomes infinitely more precious. The universe isn't the sea of stars we see at night. It is a sea of nothing, and in that sea are a few, scattered, luminous islands. We are living on one of them. The mind-bending scale of intergalactic space isn't a cause for despair. It's the ultimate context. It's the black velvet on which the jewel of our existence is displayed. The profound emptiness of the cosmos is precisely what makes the asterisk something our planet, our lives, our consciousness the most extraordinary miracle of all. If this journey expanded your perspective, be sure to subscribe and join us for more explorations into the great unknown. And let us know in the comments, what part of this journey was the most mind-bending for you?
Part 2. What a galaxy really is. Before we can understand how big the space between galaxies really is, we have to slow down for a moment and ask a simpler question. What exactly is a galaxy in the first place? It is one of those words most of us have heard since childhood. Galaxy. A grand, beautiful word. It sounds enormous, mysterious, and a little distant. But if someone stopped us and asked what a galaxy actually is, in plain language, many of us would probably say something like, well, a bunch of stars. And that is not wrong, but it is also not nearly enough. A galaxy is not just a bunch of stars. It is more like a vast gravitational family. A single, giant system held together by gravity, shaped over billions of years, and filled with far more than points of light. Stars are the most obvious part, because stars are what shine. They are what catch the eye. But a galaxy also contains planets, moons, gas, dust, magnetic fields, dead stars, newborn stars, black holes, and something even stranger than all of those things combined, a huge invisible presence called dark matter. And tonight, before we drift further outward into the enormous silence between galaxies, we are going to stay with the galaxy itself for a while. We are going to make it feel real. Not as a diagram in a textbook, and not as a glowing spiral in a computer image, but as a place, a structure, a true cosmic environment. Because once you really understand what a galaxy is, the emptiness outside it becomes much more astonishing. The easiest mistake to make is to imagine a galaxy as something crowded. After all, when you see those beautiful images of the Milky Way or Andromeda, the light looks thick and dense, almost like cream stirred into dark coffee. It gives the impression that galaxies are packed, that stars must sit close together in some kind of glittering swarm. But the reality is much quieter than that. A galaxy is full of things, yes, but it is also mostly empty. Even inside a galaxy, emptiness is already the rule. That is worth pausing on. We often think of intergalactic space as the great void, and it is. But the lesson begins earlier than that. Even a galaxy, this gigantic island of matter in the universe, is itself mostly space. The stars are scattered across distances so immense that if you could somehow travel from one typical star to the next, you would spend most of that journey moving through darkness. So a galaxy is not a crowded city in the way we normally think of a city. It is more like a city where each house is separated from the next by thousands of miles of open land. The city still exists. The houses still belong to it, but the space between them dominates the experience. If we use our own home galaxy, the Milky Way, as an example, this becomes easier to feel. The Milky Way is the galaxy that contains our Sun, our solar system, our Earth, and everyone who has ever lived. It is home, in the largest sense that word can carry. And yet even here, in our own galactic neighborhood, the distances are beyond ordinary human intuition. The nearest star system to our own is over 4 light-years away. Light, which can circle Earth more than 7 times in 1 second, still takes more than 4 years to get there. That is just the next system over, inside the same galaxy. So when we talk about a galaxy, we are not talking about a tight cluster of nearby lights. We are talking about an immense region where gravity has gathered matter into one long-lasting structure, even though that matter may be spread across tens of thousands, or even hundreds of thousands, of light-years. That word gravity matters more than almost anything else here. Gravity is the quiet architect of a galaxy. It is what makes a galaxy, instead of just loose material drifting apart forever. Without gravity, the stars, gas, and dust would simply scatter. There would be no spiral arms, no galactic center, no stable orbit for the sun, no long story of stars being born and dying and enriching the cosmos. Gravity is the force that gathers, shapes, and holds. But the galaxy gravity creates is more layered than most people realize. At the most obvious level, there are stars. Stars are the luminous anchors of galactic structure. Some are small and cool, red and faint. Some are huge, hot, and blue. Some are old, swollen, and unstable. Some are already dead, collapsed into white dwarfs, neutron stars, or black holes. A galaxy contains stars at every stage of life. In that sense, a galaxy is not just a place. It is an ecosystem of stellar birth, growth, aging, death, and renewal. Between those stars lies gas, mostly hydrogen, along with helium and traces of heavier elements. That gas matters because it is the raw material for future stars. In some regions of a galaxy, the gas is thin and quiet. In others, it gathers into cold, dense molecular clouds. These clouds can become stellar nurseries, places where gravity slowly squeezes matter inward until new stars ignite. The night sky, peaceful as it seems, is part of a much larger cycle. Galaxies are not static museums. They are active, evolving systems. There is also dust, though dust in space is not like dust on a bookshelf. Cosmic dust is made of tiny grains of heavier elements, bits of carbon and silicates and other materials forged in the lives and deaths of stars. It drifts through the galaxy, helping shape clouds, absorb light, and seed future worlds. In a strange and beautiful way, some of the matter that once glowed inside ancient stars may later become part of planets, oceans, or living things. That is one of the calmest and most remarkable facts about galaxies. They recycle themselves. Stars do not simply shine and vanish. They change the galaxy as they live. They fuse simple elements into heavier ones. They push material outward in stellar winds. Some explode as supernovae, scattering enriched matter across space. That material then becomes part of new clouds, new stars, new planets. So a galaxy is not just a container. It is a long-running process of transformation. The carbon in a human body, the oxygen we breathe, the iron in our blood, all of it came from stars that lived and died long before the sun was born. To understand a galaxy is to understand that it is, in part, a machine for making complexity. And yet even stars, gas, and dust do not tell the full story. There is also dark matter, which may be the strangest and most important part of all. Dark matter does not shine. It does not reflect light. We do not see it directly. But galaxies behave as though enormous amounts of invisible mass surround them. When astronomers study how stars orbit within galaxies, they find that the visible matter alone is not enough to explain the motion. Something else is there, adding gravitational pull. That something is what we call dark matter. If visible stars are the lanterns of a galaxy, dark matter is the invisible scaffold. In fact, the dark matter surrounding a galaxy may extend far beyond the bright disk we usually picture. So when you look at a classic image of a spiral galaxy, you are only seeing the glowing core of something much larger. The galaxy does not end where the light ends. Its gravitational reach stretches farther out into darkness, into a vast halo of unseen mass. This is one reason the edge of a galaxy is not as simple as it sounds. If I asked where a country begins or ends, you could point to a border on a map. If I asked where an island ends, you could point to the shoreline. But a galaxy has no sharp coastline. The stars become thinner. The gas becomes more diffuse. The visible glow fades. The dark matter halo continues. The boundary softens into uncertainty. That soft edge matters for our larger question, because it means the space between galaxies is not like the gap between two buildings. It is more like the gradual darkening between two faint, faraway islands whose outer influence stretches well beyond their visible shores. Our own Milky Way gives us a gentle way to picture this. The Milky Way is a spiral galaxy. That means it has a flattened disk with spiral arms winding outward from a brighter central region. If you have ever seen those elegant images of spiral galaxies, with their curved arms and glowing core, the Milky Way belongs to that family. But because we live inside it, we cannot simply step outside and photograph it from above. We see it from within, as a long band of hazy starlight crossing the sky in dark places. That pale river of light is not a cloud. It is the combined glow of countless distant stars packed along the plane of our galaxy. Our solar system sits in one of the Milky Way's spiral arms, or more precisely, in a smaller structure often called the Orion Arm or Orion Spur, between larger arms. We are not near the center. We live far out in the galactic disk, roughly halfway between the center and the outer edge. That position is probably one reason the sky is calm enough, and the environment stable enough, for complex life to have emerged here. Closer to the galactic center, conditions may be more intense, with denser star fields, more radiation, and stronger gravitational influences. At the center of the Milky Way lies a supermassive black hole called Sagittarius A star. The name sounds dramatic, and the object is dramatic, but it is important not to imagine it as some cosmic vacuum cleaner swallowing the whole galaxy. Black holes do not work like that. The central black hole is massive, yes, but the galaxy is enormous. The stars far from the center do not simply spiral inward. They orbit, just as planets orbit the sun. Gravity shapes order as much as it causes collapse. That is an important shift in perspective. In popular imagination, space often sounds violent and chaotic, and it can be. But galaxies are also structures of long-term balance. Stars orbit the center. Clouds drift. New stars form. Old stars fade. Entire regions of the galaxy can remain relatively stable for immense stretches of time. The Milky Way has been carrying stars around its center for billions of years, and our Sun is one of them, moving in a wide orbit that takes roughly a couple 100 million years to complete. By the time the dinosaurs appeared on Earth, the Sun had already circled the galaxy many times. Since the dinosaurs vanished, it has not even completed one full orbit. That scale is part of what makes a galaxy so difficult to feel. A human life is too short. Human history is too brief. Even civilizations rise and fall in moments compared to galactic time. A galaxy moves slowly, but it lives long. It changes, but in gestures so broad that whole species can come and go between one phase and the next. And the Milky Way is only one kind of galaxy. Some galaxies are spiral, like ours, elegant and structured, with disks and arms and ongoing star formation. Some are elliptical, more rounded or stretched, often filled with older stars and less active in making new ones. Others are irregular, looser and less symmetrical, shaped by collisions, turbulence, or unusual histories. So the word galaxy does not mean one single shape. It means a class of enormous gravitational systems, each with its own architecture and past. That past is often shaped by encounters. Galaxies can pass near each other. They can pull on each other. They can merge. And when galaxies merge, it is not usually like two solid objects crashing together. Remember, galaxies are mostly empty space. The stars are so far apart that direct star-to-star collisions are rare. Instead, the structure of the galaxies changes through gravity. Their shapes distort. Gas clouds compress. New waves of star formation can ignite. Over time, two galaxies may slowly become one larger galaxy. This is one of the most interesting calm facts in astronomy. Galaxies are not fixed forever in their current forms. They interact. They grow. They change families. In the very distant future, the Milky Way and the Andromeda Galaxy are expected to merge. Not tomorrow, not soon, but on timescales of billions of years. Long after the present world is gone, long after the continents and oceans of Earth have changed beyond recognition, our galaxy and its nearest major neighbor may become a single larger system. So even galaxies, which seem almost eternal to us, are part of a bigger unfolding story. And yet, for all this motion and transformation, a galaxy still feels like an island. A great island of matter in a much darker sea. That image is helpful, because it reminds us of two things at once. First, a galaxy is not just a random scattering of stars. It is a coherent structure, with identity and history. Second, even an island is defined partly by what surrounds it. A galaxy makes sense not only because of what is inside it, but because of the emptiness beyond it. That is why this part matters so much. If you do not know what a galaxy really is, then intergalactic space remains abstract. But once a galaxy becomes real in the mind, once you picture its stars, its gas, its dust, its halo, its long slow rotation, its black hole, its dark matter, its soft fading edge, then the space beyond it becomes something much more powerful. It becomes the distance outside a home, outside a structure, outside a place where things happen. And maybe that is the quiet emotional truth behind all of this. Galaxies are where the visible drama of the universe gathers. They are where stars are born, where worlds can form, where chemistry becomes richer, where light pools in the darkness. They are not everything, but they are where much of the visible story lives. So before we continue outward, it is worth holding that image gently in mind. A galaxy is a vast gravitational island. It is made of stars, but not only stars. It contains gas, dust, planets, dead suns, newborn suns, black holes, and invisible mass. It has structure, movement, and memory. It is mostly empty, and yet it is still one of the richest environments in the universe. And even its edge is not really an edge, but a fading conversation between light and dark. If these slow journeys through the universe help you rest a little more deeply, you can quietly support the channel with a like, and if you'd like more calm explorations like this, you're very welcome to subscribe. And if you feel like it, you can leave a comment sharing where in the world you're listening from tonight. For now, though, just stay here with the picture. Imagine the Milky Way from far away, not as a bright symbol on a screen, but as a true object in the dark. A wide spiral of stars turning slowly through cosmic night. A central glow. Faint arms. Clouds of gas. Dark lanes of dust. A hidden halo stretching farther than the eye can see. Our sun, somewhere out on one arm, so ordinary and so small that it would vanish into the larger light. And around all of that, beyond the last easy glow, the darkness beginning. That is a galaxy. And once you understand that, the next question becomes even more haunting. If a galaxy is already so vast, so layered, so full, then how empty must the universe be in the space between one galaxy and the next? Send me the next instruction when you want me to continue to part 3. Part 3: What intergalactic space really means. When most people hear the phrase intergalactic space, they imagine a kind of perfect nothing. A black emptiness so complete that it barely deserves to be called a place at all. Just darkness, distance, and silence. A gap between the real things. A pause in the universe. A blank stretch between one galaxy and the next. But the universe is rarely that simple. Intergalactic space does feel empty, and on the largest emotional level, it is. It is one of the loneliest environments we can imagine. And yet if we slow down enough, and if we look closely enough, that emptiness begins to reveal texture. Not the texture of forests, oceans, or weather. Not the texture of cities or mountains or clouds. Something far more delicate than that. A faint, nearly ghost-like structure. A presence so thin that calling it something still feels almost like calling it nothing. And that is what makes it so fascinating. Because intergalactic space is not just the absence of galaxies. It is its own environment. That is the idea we are going to settle into now. Not in a rushed, technical way, but gently. Because before we can truly feel how large intergalactic space is, we need to understand what we are actually talking about. What counts as being inside a galaxy, and what counts as being outside it. What changes when you leave the shelter of a galactic system behind? And what remains, even in places that seem almost empty beyond comprehension? In everyday language, the phrase is simple enough. Intergalactic space means the space between galaxies. That much is true. But in the universe, even simple definitions have blurry edges. A galaxy, as we explored a moment ago, is not a solid object with a sharp border. It does not end the way a wall ends, or a shoreline, or the edge of a table. A galaxy fades. Its bright stars become fewer. Its gas becomes thinner. Its visible shape dissolves into darkness. Its gravitational influence keeps reaching outward, long after the last obvious glow has disappeared. So when do you actually leave a galaxy? That is not a trivial question. If you were traveling outward from the Milky Way, you would not pass through a clear gate marked "Now leaving galaxy." There would be no sign, no sudden cliff, no dramatic shift from one material to another. Instead, you would move through layers. Dense regions to thinner ones. Star-filled space to star-poor space. Bright structure to faint structure. Dust lanes to sparse gas. The luminous disk would thin out behind you. The halo would still surround you. The gravitational pull of the galaxy would still matter. And only gradually would you drift into a realm where the galaxy was no longer the main environment shaping your surroundings. This is one reason intergalactic space is so difficult to picture. It is not entered with a single step. It is entered by degrees. And perhaps that is already a beautiful lesson in itself. Even in the largest structures of the universe, boundaries are often more like transitions than lines. Nature prefers gradients. Fading. Blending. The cosmos does not divide itself with a ruler. Still, astronomers do make useful distinctions. Inside a galaxy, or closely around it, matter is more clearly associated with that galaxy's own structure. Its stars belong to it. Its gas clouds belong to it. Its dust, its central black hole, its dark matter halo, all of these are part of the system. Around many galaxies there is also a vast, faint envelope of gas called the circumgalactic medium, a kind of extended surrounding region that is still influenced by the galaxy and connected to its life cycle. Gas can flow into it. Gas can flow out of it. Material from dying stars and galactic activity can reach into it. It is already very thin, already very dim, but it is not yet truly the wider space between galaxies. Beyond that, you begin to enter what astronomers usually mean by the intergalactic medium. That phrase may sound technical, but the idea behind it is quite simple. It means the extremely thin material that exists in the regions beyond individual galaxies, stretched across the larger cosmic landscape. And yes, there is material there. Not much. Not remotely much by everyday standards. Not enough to satisfy our instinct for substance. But not literally nothing. This is important, because human imagination tends to divide reality into full and empty. We think in opposites. There is land or sea, sound or silence, object or void. But the universe often lives in the space between categories. Intergalactic space is one of the best examples of that. It is emptier than almost anything we can meaningfully compare it to, and yet it still contains matter, energy, structure, and history. Mostly, that matter is hydrogen, the simplest and most abundant element in the cosmos. Just lone atoms, or ionized gas, scattered so thinly that even calling it gas can feel misleading if you picture anything like air. The air around you now contains an unimaginable number of molecules in every tiny volume. Intergalactic space does not work like that. Its particles may be separated by huge distances on atomic scales. A cubic meter of intergalactic space, a volume about the size of a washing machine, may contain only a tiny handful of particles, or even fewer, depending on where you are. Try to feel that for a moment. Imagine an enormous region where a box as large as a room, or larger, would still be almost completely empty. Then stretch that emptiness not for meters or miles, but for millions of light years. That begins to hint at what intergalactic space means. And yet those few particles matter. They matter because they tell us the universe is not a set of disconnected islands floating in a truly blank void. Galaxies are not completely isolated. There is a faint cosmic background between them, a sparse medium through which matter can move and energy can travel. In some places that medium is hotter than most people would guess. In some places it is shaped by gravity on enormous scales. In some places it forms strands and filaments so vast that entire galaxy clusters seem to sit along them like dew along invisible threads. But we are getting slightly ahead of ourselves. For now, it is enough to say this: intergalactic space is not a hard vacuum in the way people often imagine. It is not utterly empty. It is simply so empty that the human brain almost gives up trying to relate to it. And that may be why the phrase can feel more emotional than scientific. Because once something becomes that empty, it stops feeling like geography and starts feeling like philosophy. It asks strange questions of the mind. What does it mean for a place to almost contain nothing? What does distance mean when there are no familiar markers inside it? What does emptiness become when it extends farther than entire galaxies? The night sky does not prepare us for this very well. From Earth, stars give the impression of abundance. Even when we know they are far apart, the sky still looks busy, dense, decorated, alive with lights. Our eyes are drawn to points of brightness, not to the dark between them. But the dark is the greater truth. It always was. Light is rare. Structure is local. Matter gathers in pockets. The rest is mostly open. Inside a galaxy, that openness already exists. Between galaxies, it becomes dominant. And to understand that dominance, it helps to compare intergalactic space with something slightly more familiar: interstellar space. Interstellar space is the space between stars inside a galaxy. Our own solar system, after all, sits in a galaxy. Beyond the outer planets, beyond the edge of the sun's wind, beyond the region where our local star is the main shaper of the environment, lies the broader space between stars. That interstellar medium is already tremendously empty. It contains a thin spread of gas and dust. It is far beyond anything we would call a vacuum in ordinary life. And yet, compared to intergalactic space, even that can feel almost populated, that contrast matters. Because galaxies are where matter has gathered. Even if stars are far apart, even if the space inside a galaxy is mostly dark, a galaxy is still a place of concentration. Gravity has drawn things together there. The gas is richer. The structure is stronger. The events are more frequent. Star birth can happen there. Supernovae can happen there. Planets can orbit there. Radiation fields, magnetic fields, and gravitational interactions are more pronounced there. A galaxy is not crowded in human terms, but it is dense relative to what lies beyond it. Intergalactic space, by comparison, is what the universe looks like when matter has not strongly gathered into one local home. That is one of the cleanest ways to define it. If a galaxy is an organized gravitational city, intergalactic space is the countryside between cities, except stretched to a scale where the countryside becomes an ocean. Not a green ocean, not a blue one, but a near black one with only the faintest traces of substance drifting through it. And even the darkness there is different from the darkness we imagine. Human darkness is usually local. A dark room, a moonless field, a road at night. But those kinds of darkness still happen inside a world full of nearby things. Walls, trees, air, ground, clouds, insects, distant city glow, and the constant presence of a planet beneath your feet. Intergalactic darkness is the darkness of absence. No nearby stars. No local sunrise. No horizon. No up or down in the ordinary sense. No familiar sky. No immediate neighborhood. If you were somehow suspended there, far from any galaxy, you would not feel like a traveler between two visible destinations unless you had instruments to guide you. You would feel, more likely, like you had been placed into a depth the human mind was never designed to navigate. This is where the emotional force of the subject really begins. Because intergalactic space is not only empty in the physical sense, it is also empty in the psychological sense. It strips away reference points. Human beings understand places by relation. We know where we are because we can compare one thing to another. A mountain beyond a river. A town beyond a highway. A star beside another star. But in sufficiently deep intergalactic space, those habits fail. There may be no nearby reference at all. Only faraway galaxies, dim and remote, scattered across blackness like the faintest possible memories of structure. And yet the universe still has continuity there. It has laws. It has faint matter. It has radiation moving through it. It has the afterglow of cosmic history. In fact, one of the quiet surprises of space is that no place is ever entirely cut off from the rest of cosmic history. Even in the deep regions between galaxies, the universe carries reminders of its origin. Light from ancient epochs still travels. The cosmic microwave background, the faint leftover radiation from the early universe, fills all of space. You would not see it with your eyes, but it is there, a whisper from a time long before galaxies formed. In that sense, intergalactic space is not empty of story. It is soaked in it, just in an extremely subtle form. That is another reason I find the phrase so beautiful. Intergalactic space sounds like a blank interval, but it is really the largest stage on which cosmic history unfolds. Galaxies are the bright actors. Intergalactic space is the vast dark theater around them, and this theater is not passive. Over immense spans of time, galaxies can exchange matter with their surroundings. Gas can fall inward from larger structures. Energy from galaxies can push material outward. Enormous jets from active galactic centers can affect surrounding regions. Collisions and mergers can fling stars and gas out into wider space. Even lonely particles drifting between galaxies may be there because some event, long ago, threw them free from a more crowded home. So when we say the space between galaxies, we are not talking about dead emptiness. We are talking about a low-density environment that still participates in the life of the cosmos. Maybe the simplest way to say it is this: intergalactic space is where the universe becomes sparse, but not absent. It is where matter thins out so dramatically that emptiness becomes the main experience, but where a careful eye still finds traces of connection. Faint gas, stray particles, ancient radiation, invisible gravitational patterns. The stretched framework of the cosmic web. It is where the universe stops feeling local and begins to feel truly large. That transition is emotionally powerful because galaxies feel like homes, even if they are unimaginably vast homes. They are where light gathers. They are where stars shine. They are where planets can exist. They are where chemistry becomes rich. To leave a galaxy, even conceptually, is to leave behind the places where much of the visible action happens. Intergalactic space begins where the universe becomes less like a neighborhood and more like a wilderness. And wilderness may actually be too warm a word. A wilderness on Earth still has weather, soil, life, movement, scent, texture, and endless sensory detail. Intergalactic space has almost none of that richness. It has existence stripped down to an austere minimum. It is not overflowing with variety at the human scale. It is nearly pure separation. That is why size alone does not fully capture it. You can tell someone that two galaxies are millions of light years apart, and the number will sound large. But until they understand what fills that gap, or rather what barely fills it, the number does not quite land. The true meaning of intergalactic space is not just distance. It is distance combined with near total emptiness. This is also where the phrase outer space can be misleading. In everyday use, outer space is often treated as one thing, the region beyond Earth. But cosmic space has different regimes. The space near Earth is not like the space beyond the solar system. The space inside a galaxy is not like the space between galaxies. And the deep voids between major structures are emptier still. The universe changes character as scale increases. We begin close to home, where the sun dominates. Then we move to interstellar space, where stars dominate. Then we move to intergalactic space, where galaxies are the nearest great structures. And beyond that, in the largest cosmic voids, even galaxies themselves can become astonishingly rare. So intergalactic space is not the final step in emptiness, but it is the first step where most human intuitions truly collapse. It is the moment when the universe stops feeling like a collection of objects and starts feeling like a collection of separations. That may sound bleak, but it does not have to be. There is another way to hear it. The universe is generous with room. So much room that even its grandest structures float with enormous distances between them. So much room that galaxies, each holding billions of stars, can still be treated as scattered islands. So much room that darkness itself becomes the dominant geography. And perhaps that is why galaxies look so precious. If everything were crowded, a galaxy would not feel special. But against the immense silence between them, every galaxy becomes something like a lantern, a place where gravity managed to gather enough matter, over enough time, for light and complexity to bloom. Seen that way, intergalactic space is not just the gap between meaningful things. It is the contrast that makes meaningful things visible. If you enjoy these slow cosmic journeys, and if they help you settle down at the end of the day, you can gently support the channel with a like, and if you want more calm explorations like this, you're always welcome to subscribe. And if you feel like leaving a quiet note below, I always enjoy hearing where in the world you're listening from. For now, just return to the image. A galaxy behind you, fading. Not vanishing all at once, but thinning. Its brighter stars are no longer a sky. Its shape is no longer obvious. Its gas halo is becoming harder to define. The last easy sense of being inside something is slipping away. Ahead of you, there is no wall of darkness waiting. Only more of the same. More thinness. More distance. More of a universe that seems almost unwilling to place things close together. This is intergalactic space. Not pure nothing, but almost. Not a blank page, but a page with only the faintest marks. Not dead, but quiet beyond ordinary quiet. A realm of sparse particles, wandering radiation, invisible structure, and distances so large that the mind keeps reaching for metaphors and still falls short. And once you really understand that, another question begins to rise almost on its own. If intergalactic space is the vast region beyond galaxies, then how do we actually measure something so enormous? How do we talk about its scale in a way the human mind can even begin to hold? That is where we will go next. Part 4. Measuring distances in space. There is a quiet point in every journey through astronomy where our ordinary words begin to fail us. At first, everything sounds manageable. Earth is a certain number of kilometers across. The Moon is a certain number of kilometers away. Mars is farther. Jupiter is farther still. We can say the numbers out loud. We can write them down. We can even admire them. But after a while, something strange happens. The numbers keep growing, and the mind, almost politely, stops trying to picture them. 1,000,000 kilometers becomes impressive. 100 million becomes abstract. 1 billion becomes a sound more than an image. And eventually, if we keep using the same ruler, distance in space starts to feel less understood, not more. That is the problem we need to solve now. Because if intergalactic space is truly the vast region between galaxies, then we need some honest way to talk about that scale. Not just with giant numbers, but with a sense of proportion. A sense of what changes as we move outward. A sense of why astronomers had to invent new units again and again, almost as if each layer of the universe demanded a new language. And really, that is what measuring space becomes. Not just arithmetic, but translation. The translation of impossible scale into something the human mind can at least begin to hold for a moment before it slips away again. Here on Earth, kilometers and miles are enough. They are human units. They belong to roads, coastlines, flights, maps, and weather reports. They belong to a world where places can be reached in hours or days. Even the size of Earth, which once felt unimaginable, can now be crossed by aircraft, satellites, and cables. Our instincts were shaped in that world. They were never designed for the architecture of the cosmos. Still, the first steps into space let us keep those familiar measures for a little while. The Moon, for instance, sits about 384,000 kilometers away from Earth. That number is large, but not too large to say. It still feels like a destination. Humanity has been there. Signals traveled there and back. We can imagine, at least faintly, the crossing. If you stop there for a moment, the moon feels like a comfortable bridge between the world we know and the larger universe beyond it. But even inside our own solar system, the old ruler begins to strain. The Sun is about 150 million kilometers from Earth. Mars is, on average, farther still, though the distance changes as both planets move in their orbits. Jupiter is hundreds of millions of kilometers from the Sun. Neptune lives billions of kilometers away. Suddenly we are not dealing with one hard-to-picture number, but a whole family of them, each huge, each sterile, each beginning to blur into the next. And this is where astronomy makes its first graceful adjustment. Instead of constantly repeating 150 million kilometers, astronomers created a unit called the astronomical unit, usually shortened to O. 1 astronomical unit is simply the average distance from Earth to the Sun. That is all. A new ruler, built from a familiar local fact. This is one of the quiet beauties of science. When reality grows too large for the old language, it invents a calmer one. With that new ruler, Earth is 1 astronomical unit from the Sun. Mars is roughly 1.5 O. Jupiter is a little over 5 astronomical units. Neptune is about 30 O. The solar system, which looked overwhelming in kilometers, becomes easier to compare. The numbers shrink. The relationships become clearer. We start to feel the shape of things instead of just being crushed by the size of them, but only for a while. Because the astronomical unit is a solar system ruler, it is useful as long as the Sun remains the center of the story. Once we leave the Sun's neighborhood, that ruler begins to feel too small, just as kilometers began to feel too small before it. This happens slowly at first. Take Pluto, distant and dim, moving through the outer reaches of the solar system. Then go beyond Pluto to the Kuiper Belt, a realm of icy objects and frozen leftovers from the formation of the planets. Then farther still, into the speculative grandeur of the Oort cloud, a vast, ghostly shell of icy bodies that may extend tens of thousands of O outward, perhaps more. Even here, still inside the greater gravitational influence of our Sun, the distances begin to feel stretched thin. The astronomical unit is still functional, but it no longer feels elegant. Counting in O at that scale is a little like measuring the distance between countries in the width of a doorway. Technically possible, spiritually unhelpful. And beyond that lies the next star. This is the moment where the universe changes tone. The nearest star system beyond our own is Proxima Centauri, about 4.24 light-years away. And that phrase, light years, introduces the next ruler. Perhaps the most famous ruler in astronomy, and one of the most misunderstood. A light year is not a measure of time. It sounds like one, and the name invites the confusion, but it is a measure of distance. It simply means the distance light travels in 1 year. That is still a large idea, so let us slow down and make it gentler. Light moves at about 300,000 kilometers per second. In 1 second, it can circle Earth more than 7 times. It is fast enough to turn space into something almost effortless. Sunlight takes about 8 minutes to reach Earth. That means when you feel sunlight on your skin, you're being touched by something that left the Sun 8 minutes earlier. If the Sun vanished, in some impossible thought experiment, we would not know it right away. For a short while, the old light would still be arriving. This is one of the first truly calming and disorienting lessons in astronomy. Even the things that feel immediate are slightly delayed. The universe reaches us through travel time. A light second, then, is the distance light crosses in 1 second. A light minute is the distance it crosses in a minute. A light hour in an hour. These are all useful when talking about the solar system. The moon is a little over 1 light second away. The Sun is about 8 light minutes away. Neptune is roughly 4 light hours from the Sun. Already, the system begins to feel more emotionally coherent. Instead of dead numbers, we begin to think in terms of travel time for the fastest thing there is. And then we stretch that idea to a full year. A light year is the distance light travels in 1 year, which is about 9.5 trillion kilometers. That number is so huge that it does not really behave like a number anymore. It behaves more like a warning, a sign that we have entered a different scale of reality. And yet light years help because they restore meaning. They tell us that when we see something far away, we are also seeing something old. Distance and time become braided together. A star 4 light-years away is seen as it was 4 years ago. A galaxy 2 million light-years away is seen as it was 2 million years ago. The farther we look, the deeper into the past we see. Space is not just large, it is historical. That may be the single most important emotional shift in cosmic measurement. On Earth, distance and time are related, but loosely. A place can be far away in space but near in time if we fly there. In the universe, that separation begins to collapse. There is no meaningful shortcut. Vast distance means ancient light. To measure space is also to measure delay. And once you understand that, the night sky changes forever. The stars do not appear as they are in this instant. They appear as messages arriving late, some only slightly late, others staggeringly late. The universe we see is not the universe now. It is the universe as news. This is part of why scale in astronomy feels different from scale in ordinary life. It is not only that things are far away, it is that their distance carries memory. Still, even light years are not equally useful everywhere. Inside a galaxy, they work beautifully. The nearest stars are a few light years away. Nebulae may be hundreds or thousands of light years away. The Milky Way itself is around 100,000 light years across, depending on exactly how one defines its visible structure and its much larger halo. Now the galaxy begins to feel like a real place. Not small, never small, but at least describable. Our sun is not near the center of the Milky Way. We live far out in one of its spiral regions, roughly 26 to 27,000 light-years from the galactic center. If you wanted to cross the galaxy, not with a spaceship but with light itself, it would take light tens of thousands of years to move from one side to the other. That sentence is worth resting inside for a moment. Light, the fastest thing in the known universe, needs tens of thousands of years just to cross our galaxy. When you start to feel that, even faintly, the Milky Way stops being a romantic smear in the sky and becomes what it really is. A continental structure of stars. A vast, thin, rotating city of light so large that human history is smaller than a footstep inside it. And yet galaxies are not the end of the story. They are only the beginning of the next one. Because once we move from the space between stars to the space between galaxies, even the light year begins to feel like a more ordinary unit. It still works, of course. But now we are speaking in millions of light years. Tens of millions. Hundreds of millions. Billions. The ruler still holds, but the mind begins to wobble again. This is why astronomers sometimes use another unit called the parsec, and larger versions such as kiloparsecs and megaparsecs. A parsec equals about 3.26 light years. A kiloparsec is 1,000 parsecs. A megaparsec is 1 million parsecs. These units are especially useful in professional astronomy because they arise naturally from certain geometric methods of measuring stars and galaxies. But to most people, and perhaps especially in a calmer kind of storytelling like ours, the light year remains the more human unit. Not because it is small, but because it carries a feeling. It reminds us that distance is measured through light itself. It preserves wonder. And wonder, in this subject, matters. Because without wonder, the measurements become sterile. They become tables and values and symbols. Useful, yes, but emotionally empty. We do not want to lose the quiet meaning of what is being measured. A galaxy is not merely 2 million light years away. Its light has been traveling for 2 million years. It set out before human civilization, before cities, before writing, before almost everything we think of as history. That is what a measurement can mean in astronomy. It can mean that the universe takes a very long time to arrive. There is another useful way to think about this, one less mathematical and more visual. Imagine each new unit as a ruler suited to a certain kind of neighborhood. Kilometers and miles belong to planets. Astronomical units belong to star systems. Light years belong to galaxies. And when galaxies begin to gather into larger structures, even bigger ways of speaking become natural. This is not arbitrary. It mirrors the architecture of the cosmos itself. As the physical scale changes, the language changes with it. The universe teaches us how to describe it by refusing to fit inside our first descriptions. You can almost feel this in the progression outward. At first, we stand on Earth and think in roads. Then we enter the solar system and think in orbits. Then we leave the sun behind and think in years of light. Then we look across intergalactic darkness and realize even years of light may need to be grouped into millions before the shape of reality becomes visible. And all of this is still only measurement. We have not even begun to talk about the feeling of traveling such distances. We are simply learning how to name them. That may sound modest, but naming is powerful. The right unit can make something visible to the mind that was previously just a blur. It can turn awe into understanding without destroying the awe. That is the ideal balance. Not to shrink the universe into comfort, but to make it just thinkable enough that wonder can deepen instead of collapsing. So let us bring the scales together gently. The moon is about 1 light second away. The sun is about 8 light minutes away. Neptune is a few light hours from the sun. The nearest star is a little over 4 light years away. The Milky Way is roughly 100,000 light years across. And the nearest major galaxy, Andromeda, is about 2.5 million light years away. Listen to how the language changes as the universe opens up. Second, minute, hour, year, thousands of years, millions of years. The unit expands because the emptiness expands. The ruler grows because the silence between things grows. It is not just that objects are bigger. It is that the gaps are bigger. And that brings us closer to the real heart of the matter. When people imagine astronomy, they often imagine the grandeur of objects. The sun, Jupiter, nebulae, black holes, galaxies. But astronomy is equally a study of intervals, of separations, of how much nothing lies between the bright things. Measurement, in space, is really the art of respecting emptiness. That is why intergalactic space is so overwhelming. Once you reach that scale, you are no longer just measuring objects. You are measuring the long dark pauses between them. If these quiet explorations help you slow down at the end of the day, you can leave a like, and if you want more calm journeys through the larger universe, you are always welcome to subscribe. And if you feel like sharing, I'd love to know where you're listening from tonight. For now, though, stay with the ruler. Imagine holding a kilometer in one hand, an astronomical unit in the other, then a light year, then a million light years. Each one is not just larger than the last. Each one belongs to a wider layer of reality. Each one is a sign that we have moved farther from home, farther from instinct, farther into a universe where distance begins to feel almost philosophical. And soon we will use that ruler for something very specific. Because it is one thing to say that galaxies are far apart. It is another thing entirely to ask how far the nearest major galaxy actually is, and what that distance really means when measured against everything we know. That is where the scale begins to turn from impressive to haunting. Part 5, the nearest major galaxy. There is a quiet difference between hearing that galaxies are far apart and actually feeling what that means. Up to this point, we have been building the idea slowly. First, a galaxy became something more than a word. Then intergalactic space became something more than a blank. Then we found the rulers we needed, from kilometers to astronomical units to light years, just to keep the universe from slipping completely out of reach. And now, with those rulers in hand, we can ask a more intimate question. Not how big the whole universe is. Not how large the largest voids are. Just something simpler, and in its own way more haunting. How far away is the nearest major galaxy? It sounds like a straightforward question, the kind of thing that should come with a straightforward answer. But once you sit with it for a while, it begins to feel less like a fact and more like a cliff edge. Because the nearest major galaxy is not far in the way a mountain is far, or a country is far, or even a star is far. It is far in a way that quietly erases the usefulness of almost every distance you have ever known. And yet it is there. In fact, if the night is dark enough, and your sky is clear enough, and you are willing to look with patient eyes, you can actually see it. Not as a grand spiral, not as a brilliant disk, not as the glowing city of stars it truly is. Just as a faint smudge, a dim, hazy patch of light, almost like a thumbprint on the darkness. Easy to overlook, easy to mistake for something smaller, nearer, less astonishing. That faint patch is the Andromeda Galaxy. Andromeda is the nearest major galaxy to our own Milky Way. Not the nearest galaxy of any kind, because there are smaller dwarf galaxies closer to us, tiny companions and satellites moving in our broader cosmic neighborhood. But if we are talking about a galaxy large enough to stand beside the Milky Way as a true peer, a major system with hundreds of billions of stars and a structure vast enough to feel like its own universe, then Andromeda is the nearest one. And it is about 2.5 million light-years away. That number is worth saying slowly. 2.5 million light-years. Light, moving faster than anything else we know, needs about 2.5 million years to cross the gulf between Andromeda and us. Which means the Andromeda we see tonight is not Andromeda now. It is Andromeda as it was when early human ancestors were walking the Earth in forms very different from our own. Long before cities. Long before agriculture. Long before writing, music, bronze, kings, temples, engines, telescopes, or names. The light arriving from Andromeda began its journey in a world so ancient that almost everything we call human history still lay ahead of it. And somehow, after all that time, some tiny part of it reaches your eyes. That is one of the most calming and strange facts in all of astronomy. Looking outward is also looking backward. And the farther we look, the older the message becomes. But let us stay with the distance first, because 2.5 million light-years is a number that can easily float past the mind without really landing. It is too clean, too easy to say. To feel it, we have to compare it to something. Our own Milky Way, the galaxy we call home, is roughly around 100,000 light-years across in its main visible disk, depending on exactly how we choose to define the edges. That is already enormous. Light needs about 100,000 years to cross it. A beam leaving one side of the Milky Way would still be traveling long after every empire in recorded history had risen and fallen. Long after languages changed beyond recognition. Long after coastlines and forests and whole human ideas of the world had transformed. And yet the Andromeda Galaxy is not one Milky Way away from us. It is not 2 or 3 or even 10. The gap is roughly 25 times the width of our galaxy's visible disk. That is what makes the distance feel so eerie. Imagine standing on one shore of a vast black ocean. Behind you is your own island, already impossibly large. Not a little patch of land, but a continent of stars. Then someone tells you that the nearest other great island is not just beyond the horizon, but across an ocean 25 times wider than your entire homeland. And not an ocean filled with waves or clouds or ships or birds, but one almost entirely empty. That begins to hint at what 2.5 million light-years means. Andromeda itself is beautiful to think about. It is a spiral galaxy, like the Milky Way, though likely somewhat larger in its visible structure. It has sweeping arms, stars by the hundreds of billions, clouds of gas, dark lanes of dust, clusters, halos, and its own long galactic history. If you could somehow drift close to it, you would not experience it as a distant smudge. You would experience it as a vast stellar civilization of nature, Another great island of matter with its own inner neighborhoods, its own ancient stars, its own planetary systems, perhaps its own worlds with quiet skies. From far away, galaxies shrink into symbols. But up close, each is a realm. That may be one of the most helpful things to remember here. Andromeda is not just the next galaxy. It is an entire major structure of the universe. If the Milky Way is home, Andromeda is the nearest other great city of stars. And between us and that city lies a gulf so wide that even the phrase between us feels too casual. This is where people sometimes ask a natural question. If Andromeda is the nearest major galaxy, what about the Magellanic Clouds? What about the smaller galaxies astronomers talk about in our neighborhood? And it is a fair question. There are indeed smaller galaxies closer to the Milky Way, including satellite galaxies bound to our own. The Large Magellanic Cloud and Small Magellanic Cloud, for example, are visible from the southern hemisphere and much closer than Andromeda. But they are dwarf galaxies, much smaller systems, more like companions than equals. When people say Andromeda is the nearest major galaxy, they mean the nearest galaxy that truly compares in size and significance to the Milky Way. That distinction matters because scale matters. It is one thing to say the nearest small satellite is nearby on cosmic terms. It is another to say the nearest truly massive galaxy is still 2.5 million light-years away. That tells us something profound about the structure of the universe. Great galaxies are not packed together. They are not stacked side by side. Even neighbors, even the nearest major neighbors, are divided by extraordinary emptiness. And yet Andromeda is still our neighbor. That sounds absurd at first. Neighbor is such a human word. It belongs to fences, streets, apartment walls, dogs barking in the next yard, lights on in nearby windows. It belongs to nearness. But astronomy has to stretch language the way it stretches measurement. At cosmic scale, neighbor means something different. It means the nearest comparable structure within the same broader region. It means the closest great island in the local sea. Andromeda and the Milky Way are part of the same broader galactic family, a collection known as the Local Group. This is a small gathering of galaxies held together by gravity, including the Milky Way, Andromeda, the Triangulum Galaxy, and many smaller dwarf galaxies. In cosmic terms, this is our immediate neighborhood, a tiny village of galaxies in a much larger universe. Even that sentence has a quiet shock inside it. A village of galaxies. On Earth, a village is intimate. A few roads. A handful of homes. A familiar map. In the universe, a village may contain multiple galaxies separated by millions of light-years. It reminds us, once again, how patiently the cosmos forces us to enlarge our definitions. The Andromeda Galaxy is also moving toward us. This is one of those facts that sounds dramatic, and in a very long-term sense it is. Over billions of years, the Milky Way and Andromeda are expected to merge. Not collide in the way two stones collide, because galaxies are mostly empty space and stars are spread incredibly far apart. But the two systems will slowly distort, interact through gravity, and eventually become one larger galaxy. Their stars will continue moving, their structures will stretch and blend, and a new galactic form will emerge from the long dance. That future is far beyond anything human. It belongs to a time when Earth itself may no longer be the kind of world we know. Still, it adds a subtle emotional layer to the distance. The nearest major galaxy is not only sitting across the dark, it is, very slowly, coming closer. But let us not rush to the future yet. For now, the present gulf is what matters. Suppose, just for a moment, that you could travel at the speed of an ordinary spacecraft. Not an old one, but something impressive by human standards. The journey to the Moon took days. The journey to Mars, depending on orbital positions and the method used, takes months. The outer planets require years. Voyager 1, one of the fastest objects humanity has ever sent outward, has been traveling since 1977 and is still only in the outer edge of our solar neighborhood. At that kind of speed, reaching Andromeda would not take thousands of years. It would take far longer than human civilization has existed. So much longer, in fact, that the journey stops being a trip and becomes something closer to geological or biological time. Continents move. Species appear and vanish. Ice ages come and go. Languages are born and disappear. All while a human-made probe would still be nowhere near that neighboring galaxy. This is where intergalactic distance begins to feel different from every other kind of distance. It does not just defeat our vehicles. It defeats our habits of thought. There is a reason the night sky misleads us. It places things side by side visually. One star here, another there, a faint glow beyond them. The eye has no built-in sense of depth on that scale. A nearby street lamp and a distant mountain can seem almost close together from the right angle. The same happens in the sky, but on a far more deceptive level. The Andromeda Galaxy looks like a small feature among other points of light. But that appearance hides a depth so vast that the mind has to learn, almost against its instincts, not to trust the flatness of what it sees. This is why astronomy can feel so humbling. It constantly reveals that appearance is the beginning of understanding, not the end of it. Andromeda is also a wonderful example of how something can be both visible and incomprehensible at the same time. You can see it with the naked eye under dark skies. That fact alone feels magical. The most distant object many people will ever see without a telescope is not a star, but an entire galaxy. A whole structure of hundreds of billions of stars. A massive, spinning island of light so far away that its glow has been traveling toward us since before humans were human in the modern sense. And yet the thing you see is tiny, soft, barely there. That contrast is one of the quiet emotional centers of this subject. Reality can be unimaginably large and still arrive as something subtle. The universe does not always announce its greatest scales with brightness. Sometimes it whispers. If you could somehow compress the Milky Way down to the size of a dinner plate, Andromeda would be another dinner plate sitting many meters away in the dark, with almost nothing in between. Different analogies produce different exact distances, of course, but the feeling is the same every time. However you shrink it, the empty gap dominates the model. The galaxies become manageable. The space between them remains the real story. That may be the most important lesson of Andromeda. At first glance, it seems like a story about a neighboring galaxy. At second glance, it becomes a story about emptiness. Because if the nearest major galaxy is 2.5 million light-years away, then the universe is not built like a cluster of glowing pearls pressed together. It is built like scattered lights across a vast dark sea. Even when galaxies form communities, even when gravity binds small groups together, the spaces remain overwhelming. Andromeda is, in a sense, the best-case scenario. It is our nearest major neighbor. The easy example. The local one. The galaxy close enough to see without instruments, close enough to study in detail, close enough to speak of almost affectionately. And even then, the gap is almost beyond emotional reach. What, then, must the larger universe be like? That question begins to open here. If even the nearest great galaxy is so far away, then maybe galaxies are more isolated than we tend to imagine. Maybe the visible universe is less like a crowded metropolis and more like an archipelago at night, with enormous black waters separating each luminous shore. Maybe the emptiness is not a side detail at all, but the main feature. That is the point where astronomy starts to change character. It stops being only about objects and becomes about intervals. The Milky Way is astonishing. Andromeda is astonishing. But the gap between them may be the more unsettling fact, because it reveals how the universe prefers to arrange its beauty. Not in dense abundance, but in separated islands. And still, even in that separation, there is relationship. The Milky Way and Andromeda belong to the same local structure. Gravity links them across the dark. Their histories are not entirely separate. Their future is not entirely separate. The gap between galaxies is enormous, but not absolute in the emotional sense. The universe does not place every object in perfect isolation. It allows connection, but on scales so vast that connection itself becomes awe-inspiring. That may be why this particular distance matters so much. It is not the biggest, not the strangest, not the farthest thing we know, but it is the first truly intergalactic distance most people can emotionally touch. It is the first moment where a galaxy ceases to be a general idea and becomes an address beyond home. 2.5 million light-years. The nearest major galaxy. A visible smudge in the dark. A whole realm of stars. A message from deep time. A neighbor across an ocean of almost nothing. If these slow journeys through space help you relax, settle in, or drift off a little more peacefully, you can gently support the channel with a like. And if you want more quiet explorations like this, you're always welcome to subscribe. If you feel like leaving a comment, I always enjoy hearing where in the world you're listening from tonight. For now, though, hold the image one more time. Behind you, the Milky Way, your own great island of light. Ahead of you, Andromeda, another one. Between them, not a river, not a cloud, not a glittering road of stars, but a gulf so wide that light itself needs 2.5 million years to cross it. And once that really settles in, another softer question begins to rise. If the space between galaxies is so vast, then what is actually out there in that darkness? Is it truly empty, or is something still floating in the quiet between those distant islands? That is where we go next. Part 6. What is actually floating in the emptiness? If you could somehow leave the Milky Way behind, drift past its fading halo, and continue outward into the dark between galaxies, there would come a moment when your instincts would tell you that nothing was left. No nearby stars. No glowing clouds. No bright spiral arms. No familiar sense of being inside a place. Just blackness. And yet that blackness would be lying to you, in the gentlest possible way. Because intergalactic space is not truly empty. It only feels that way because the things out there are so thin, so faint, and so widely scattered that the human mind almost rounds them down to zero. We see darkness and assume absence. But the universe, even in its loneliest regions, still refuses to give us perfect nothing. There is always a trace. A remnant, a whisper of matter, energy, and structure hanging on in the quiet. That is what we are going to settle into now. Not the size of the gap, not yet. Not the great architecture of the cosmic web, not fully. Just the simple, haunting question that naturally comes once you realize galaxies are separated by such enormous distances. What is actually out there? If the space between galaxies is not completely empty, then what floats in that darkness? What survives in the vast cold gulf between one island of stars and the next? What would you pass through, very slowly, if you spent millions of years crossing the intergalactic night? The answer, like so many things in astronomy, is both less dramatic and more beautiful than people expect. There are no great flocks of objects drifting between galaxies. No hidden oceans. No dense fields of debris. No secret brightness waiting just beyond the edge of sight. The truth is much subtler than that. Intergalactic space contains matter, but in traces. It contains energy, but in whispers. It contains motion, but on scales so broad and patient that they barely feel like motion at all. And maybe that is what makes it so powerful. Even in the most empty places we can imagine, the universe still carries on. The most common thing floating in intergalactic space is the simplest element of all, hydrogen. Not in thick clouds like the clouds we see on Earth. Not even in anything close to what we would call a cloud in ordinary life. More like isolated atoms or extremely thin plasma, spread across regions so vast that even a cubic meter of space may contain only a tiny number of particles. sometimes just a few, sometimes fewer. In denser large-scale regions, more than that. In deep voids, less. But always astonishingly little. That is the first thing to understand. When astronomers say there is gas between galaxies, they do not mean gas in the human sense. They do not mean something you could breathe, or push your hand through, or watch swirl in visible patterns. Intergalactic gas is so thin that if you could gather all of it from a large region into one place, it would still feel ghostly. It is matter reduced to almost the smallest presence matter can have and still be meaningfully there. Most of it is hydrogen, because hydrogen is the simplest and most abundant element in the universe. A smaller amount is helium. And then, in traces even fainter still, there are heavier elements, things like oxygen, carbon, silicon, iron, atoms forged inside stars long ago and later thrown outward by cosmic events. That detail matters more than it may seem at first. Because if heavier elements exist in the space between galaxies, even in tiny amounts, it means the space between galaxies is not untouched. It has been shaped, enriched, stirred, very slowly, by the lives and deaths of stars. In other words, galaxies do not keep all of their matter to themselves forever. Over billions of years, some material leaks out. Some is blown outward in winds driven by star formation. Some is hurled away when stars explode as supernovae. Some is stripped during galactic interactions and mergers, pulled into the dark between systems by tidal forces, gravity, and long, patient disruption. A galaxy is not a sealed container. It exchanges matter with its surroundings, and the surroundings remember. That is one of the calmest and most surprising truths about intergalactic space. It is not separate from galactic life in the way an empty room is separate from the people who once stood in it. It is more like the air after a song has ended. The notes are gone, but traces remain. Something has passed through. Something has changed the atmosphere. And some of that intergalactic gas is not cold in the way people assume. This is where the imagination often trips. We hear empty space and think of freezing nothingness. And yes, intergalactic space can be bitterly cold by ordinary standards, especially far from energetic environments. But parts of the material between galaxies, especially in larger structures like galaxy groups and clusters, can also be extremely hot. So hot, in fact, that the atoms are ionized, meaning electrons have been stripped away. What remains is plasma, a thin, superheated state of matter. That sounds almost contradictory at first. How can something be both incredibly hot and almost empty? But temperature in physics is not the same thing as comfort. It is about the energy of particles, not how warm a place would feel on skin. A single fast-moving particle in a nearly empty region can carry high energy, even though there are so few particles around that there is almost nothing there to transfer that energy in the way we normally experience heat. So intergalactic space can contain plasma at enormous temperatures while still remaining, in the human sense, profoundly empty and lifeless. That is a very space-like truth, really. The universe often gives us combinations that sound impossible only because our bodies were not built to meet them. So there is gas out there, and sometimes plasma. Thin, sparse, nearly invisible, but real. There is also light. Not the kind of strong light that would suddenly illuminate the void. Not beams or glowing skies. But radiation does pass through intergalactic space constantly. Photons from stars. Photons from galaxies. Photons from quasars, those intensely bright galactic cores powered by feeding supermassive black holes. And older than all of these, more uniform and more ancient, the faint afterglow of the early universe itself, the cosmic microwave background. This may be one of the strangest things to imagine. Even in deep intergalactic darkness, you would not truly be cut off from light. You might see very little with your eyes, depending on your location, but the universe is still full of radiation crossing the dark. Ancient photons from the early cosmos are moving through you. Light from distant galaxies is sliding past through the emptiness. Messages from across time continue to travel, even where almost no matter is gathered. So the darkness between galaxies is not a dead blackout. It is more like a cathedral after midnight, vast and dim, with faint echoes still traveling through the air long after the visible activity has gone. There are also high-energy particles moving through intergalactic space, what we often call cosmic rays. Some are born in violent events like supernovae. Some may come from active galactic nuclei or other extreme environments. They race through the universe with extraordinary energy, crossing great distances through regions that otherwise feel almost still. Again, this changes the emotional picture of emptiness. The space between galaxies is not crowded, but it is not inert. Particles move through it. Radiation crosses it. Invisible histories pass silently from one structure to another. The void is quiet, but it is not asleep. And then there are magnetic fields. This surprises many people because magnetism feels like something local, something belonging to refrigerator doors, compasses, electric motors, and planets. But magnetic fields also exist on astronomical scales. Galaxies have them. Clusters of galaxies have them. Even the larger regions between galaxies may contain faint magnetic fields, incredibly weak compared with what we are used to on Earth, but stretched across immense distances. These fields are difficult to detect and study, and we are still learning how they form, evolve, and spread. But their existence tells us something profound. Even intergalactic space is not just a neutral blank. It has properties, texture, influence. It can guide the motion of charged particles. It can preserve traces of ancient cosmic processes. It can carry the memory of energetic events that happened billions of years ago. That phrase may sound poetic, but it is also true in a physical sense. The universe stores history and structure, and intergalactic space stores it in a very faint way. There is another possibility floating out there too, one that people often find strangely moving: lonely stars. Not many, compared with the stars inside galaxies. Not enough to brighten the dark in any dramatic way. But some stars do exist outside the obvious boundaries of individual galaxies, especially in galaxy clusters and in the aftermath of gravitational interactions. These are sometimes called intergalactic stars, or intracluster stars, depending on the environment. They are stars that drift in the wider space between galaxies, no longer clearly belonging to one single galactic home. How do stars end up there? Usually not because they were born in perfect isolation, though that can be discussed in rare cases. More often, they were pulled free. Galaxies passing close to one another can distort each other through gravity. Mergers can fling stars outward. Tidal forces can stretch and scatter entire streams of matter. A star that once orbited comfortably inside a galaxy may, over immense timescales and under the right circumstances, find itself wandering the larger darkness between systems. There is something quietly melancholy about that. A star, still burning, still shining, but no longer clearly inside the bright family it came from. A sun with no obvious galaxy around it, or at least no nearby one dominating its sky in the way our own galaxy dominates ours. Not completely alone in the universe, because nothing ever truly is, but cosmically displaced. And where there are stars, one naturally wonders whether there could also be planets. This is the kind of question that tempts the imagination, and it is a fair one. If stars can be stripped from galaxies or wander in the spaces between them, then in principle planets may travel with them, or smaller free-floating worlds may exist as well. Astronomy has already taught us that rogue planets, planets not bound to any star, may drift through galaxies. So it is not unreasonable to imagine that some worlds might also roam in broader, darker regions under certain circumstances. But this is not something we should picture as common scenery in the intergalactic void. It would be rare, faint, and difficult to detect. More a haunting possibility than a defining feature. Still, it tells us something about the universe that matters here. Even the emptiest regions may contain the leftovers of older stories. Not bright stories, not crowded ones, but remnants. And remnants are often enough to make emptiness feel more alive. There is also dust, though again, very little of it compared with what exists inside galaxies. Dust grains can be carried outward by winds and violent events. Some may linger in the larger medium around and between galaxies. Dust matters because it interacts with light. It absorbs, scatters, and re-emits radiation. Even in tiny amounts, it becomes part of the invisible relationship between galaxies and the wider space around them. What fascinates me most about all of this is how modest the ingredients sound when listed one by one. A little hydrogen, a little helium, some ionized plasma, faint radiation, high-energy particles, weak magnetic fields, a few wandering stars, possible orphan worlds, traces of dust, scattered heavier elements forged long ago. None of it sounds grand on its own. None of it sounds like the kind of thing that should dominate imagination. And yet when you place those ingredients inside the largest emptiness most people will ever seriously contemplate, they become extraordinary. Because they mean the universe never quite reaches perfect absence. It always leaves something behind. Even more quietly than that, these ingredients are not evenly spread. Intergalactic space varies. Some regions are denser, especially around galaxy groups and clusters, where gravity gathers matter and heats gas to very high temperatures. Other regions are thinner, far thinner. In those deeper stretches, especially in cosmic voids, matter becomes so sparse that the word emptiness feels almost completely justified. But even then, the universe is not a mathematical zero. It is simply approaching it. And perhaps that is one of the deep themes running through this whole subject. The universe seems to love gradients more than absolutes. Not full or empty, but fuller here and emptier there. Not light or darkness, but brighter islands and darker oceans. Not presence or absence, but a long fading from one into the other. That fading is what makes intergalactic space feel so haunting. Because when most of us imagine distance, we imagine travel through clear stages. You leave one place, then you enter another. But in the real universe, especially at these scales, you often leave by degrees. The galaxy becomes less dominant. The gas becomes thinner. The stars become fewer. The local brightness fades. And then, somewhere in that long transition, you realize you are in the larger silence now. Yet the silence still has content. That may be the simplest answer to our question. What floats in the emptiness between galaxies? Almost nothing, but not nothing. Matter stripped to a trace. Energy stretched thin. Faint structure barely visible. Particles moving through a darkness so broad that even a few atoms become meaningful. And perhaps this is why intergalactic space can feel more emotionally powerful than a crowded scene. Crowded scenes give the mind something easy to hold. Objects, shapes, events, motion. But near emptiness asks for a different kind of attention. A slower attention. A more patient one. The kind that notices what remains when almost everything else is gone. It is a little like standing by the sea very late at night, when the coastline has disappeared into shadow and the world seems made mostly of darkness and sound. At first, it feels empty. Then you stay longer. You begin to hear small things. A distant movement of water. Wind across the surface. The occasional glint of light. Emptiness becomes layered. Intergalactic space is like that, except with scales so vast that the comparison almost breaks. And still, comparisons help. Because no human being is built to directly feel 1 atom per cubic meter. No instinct evolved to picture stray photons crossing millions of light years. No body knows how to imagine magnetic fields stretched across intergalactic dark. So we rely on gentler ways of understanding. Story, image, patience. We imagine the darkness not as sterile nothingness, but as a place where the leftovers of cosmic history drift in extraordinary thinness. We picture ancient atoms, some formed not long after the beginning of the universe, others forged later inside stars, now spread so far apart that they almost cease to feel like matter at all. We picture wandering light crossing the gulf. We picture the occasional lonely star, exiled by gravity, continuing to burn in a place that offers no company. And then the emptiness becomes more than an empty idea. It becomes an environment. A very quiet one, a nearly absent one, but real. There is also a deeper beauty in knowing that some of the material floating between galaxies may one day become part of galaxies again. Gravity never fully stops working. Matter can drift, fall, heat, cool, and gather over immense timescales. What looks like loss from one point of view may become future structure from another. Gas in the larger cosmic environment can feed galaxies. Outflows from galaxies can enrich the environment. The relationship is long and slow, but it exists. So the space between galaxies is not merely what lies between meaningful things. It is part of the larger circulation of the universe. That idea matters. Because otherwise we might imagine galaxies as isolated jewels and intergalactic space as irrelevant darkness. But the real cosmos is subtler than that. The darkness participates. The faint medium participates. Even near emptiness has a role in the ongoing exchange of matter and energy across cosmic time. If these slow explorations help you settle down and drift a little deeper into rest, you can quietly support the channel with a like. And if you'd like more calm journeys through science and the cosmos, you're always welcome to subscribe. If you feel like leaving a comment, I always enjoy hearing where you're listening from tonight. For now, though, return one last time to the image. You are far from any galaxy. The nearest great spiral is only a dim suggestion behind you. Ahead, another is waiting at a distance so large it hardly feels real. Around you, there is no dramatic spectacle, no sudden burst of hidden life. Only the faintest presence of matter. Hydrogen atoms scattered through the dark. Thin plasma holding the heat of ancient processes. Invisible magnetic fields stretched like whispers across the void. Radiation passing silently through. Perhaps a lonely star somewhere in the deep, carrying its own little circle of light through a realm that barely acknowledges light at all. This is what floats in the emptiness. Not enough to fill it. Not enough to make it feel crowded. Only enough to remind us that the universe, even at its quietest, never becomes perfect nothing. And once you know that, another question begins to unfold naturally. If matter is spread so thinly between galaxies, then why does the universe arrange itself this way at all? Why do galaxies gather in some places while other regions become so empty that they feel almost abandoned? That is where we go next. Part 7. Why intergalactic space looks so empty. At first, the emptiness between galaxies can feel almost unfair. You learn that a galaxy contains hundreds of billions of stars, vast clouds of gas, dust, planets, black holes, and invisible halos of dark matter. You begin to picture it as a great shining city in the dark. And then, almost immediately, you are told that the next major galaxy may be millions of light years away, with almost nothing in between. It is such a dramatic contrast that the mind resists it. Why should the universe arrange itself this way? Why gather so much in one place, then leave such enormous stretches of near nothing all around it? It would almost be easier to imagine a different universe. A universe where matter was spread more evenly. A soft, glowing mist of stars across all directions. No great gulfs. No long black intervals. No isolated islands. Just a full and luminous cosmos, comfortably crowded. But that is not the universe we live in. Our universe prefers contrast. It prefers gathering and separation. It prefers knots and gaps, filaments and voids, bright places and dark expanses. And the reason for that, at its deepest level, is not that emptiness is a mistake. Emptiness is part of the design, or perhaps a better word would be consequence. It is what naturally happens when matter begins unevenly, when gravity starts pulling, and when the fabric of the universe itself keeps expanding underneath the whole story. Tonight, we are going to stay with that idea, not in a rushed or mathematical way, but gently. We are going to ask why intergalactic space looks so empty, and why the visible universe is not distributed like dust on a table, but instead gathered into these enormous, separated structures we call galaxies. Because once you understand that, the emptiness between galaxies stops feeling random. It begins to feel inevitable. The story starts very early, long before there were galaxies at all. In the beginning, the universe was hotter, denser, and far more uniform than it is now. Not perfectly uniform, but close. If you could somehow have looked at the infant universe, you would not have seen spiral galaxies hanging in darkness. You would not have seen stars, planets, or black holes. You would have seen something much more diffuse, much more even, a young cosmos in which matter and energy were spread across space with only tiny variations from place to place. Those tiny variations are everything, because the early universe was not perfectly smooth. In some regions, matter was ever so slightly denser than average. In others, ever so slightly less dense. The differences were extraordinarily small, almost laughably small compared with the immense structures they would one day help create. But gravity is patient. Gravity does not need dramatic beginnings. It only needs a slight advantage, and enough time. Where matter was a little denser, gravity pulled a little harder. And where gravity pulled a little harder, more matter drifted in. And where more matter drifted in, the region became denser still, which made gravity stronger still, which pulled in even more matter. This is one of the quietest and most powerful feedback loops in the universe. A place that begins slightly denser becomes a place that grows denser. A place that begins slightly emptier loses the contest. Matter flows away from it, toward the stronger gathering points elsewhere. Over immense spans of time, tiny differences become giant outcomes. That is the first reason intergalactic space looks so empty. Matter did not stay evenly spread. Gravity began collecting it into structures. And when matter collects somewhere, it necessarily leaves somewhere else. This is easier to feel with a much smaller image. Imagine rain beginning to form on a cold window. At first the moisture is thin and almost even, just a soft film across the glass. But soon tiny droplets begin to gather. A little water joins another little bit of water. The droplet grows. That larger droplet attracts still more moisture, while nearby regions become clearer and drier. Before long, the window is no longer covered evenly. It is patterned. Clusters and gaps. Droplets and empty stretches. The water has not vanished. It has simply reorganized itself. The universe does something like that, but with matter and gravity on scales so vast that the comparison almost breaks. Once you see that, emptiness stops feeling like the opposite of structure. It becomes the partner of structure. Galaxies are where matter gathered. Intergalactic space is what became relatively depleted because of that gathering. And gravity did not work alone. There is another invisible ingredient in this story, one so important that galaxies as we know them likely could not have formed without it. Dark matter. Dark matter does not shine, and we do not yet know exactly what it is. But its gravitational influence appears throughout the cosmos. It helps build the scaffolding on which ordinary matter gathers. In the early universe, dark matter began forming the broad gravitational framework first. Regular matter, the matter that makes stars, planets, gas, and people, fell into those invisible structures later. So when we look at the universe and see galaxies forming in certain places, part of what we are really seeing is ordinary matter collecting along a deeper, hidden architecture. This matters because it means the universe was not simply deciding at random where galaxies should appear. The large-scale structure had underlying guidance. Dark matter shaped the wells. Ordinary matter flowed into them. Stars ignited. Galaxies formed. And the regions between those gravitational highways became emptier by comparison. This is also why intergalactic space can feel more empty than we expect from a universe with so much total matter in it. A very large fraction of the matter is not arranged as isolated particles sprinkled evenly across all of space. It is concentrated, pulled into halos, galaxies, groups, clusters, filaments. And concentration, by definition, creates contrast. There is a gentle rule hiding underneath all this. The universe does not need to remove matter to create emptiness. It only needs to move matter unevenly. That single idea explains a great deal. If you gathered the people in an entire country into a handful of giant cities, the countryside between them would begin to feel deserted, even though the total number of people had not changed. The emptiness would be relational. It would be created by clustering. In the same way, the vast black regions between galaxies are not empty because matter disappeared. They are empty because matter gathered elsewhere more strongly. And galaxies themselves keep reinforcing this pattern. Inside a galaxy, gravity continues shaping local structure. Gas clouds collapse into stars. Stars live and die. Spiral arms organize the disk. Mergers and interactions alter the form. The galaxy becomes an increasingly rich place compared with the wider space around it. Over time, the contrast between inside and outside grows emotionally sharper. The galaxy becomes a realm of activity. Intergalactic space becomes the place between realms. But gravity is only half the story. Because if gravity were the only major force shaping the large-scale cosmos, the universe might have become increasingly clumpy and connected in a way that feels more intuitively crowded. Structures would still form, yes, but gravity alone would constantly be trying to pull things together, to overcome distance, to gather matter into larger and larger associations. Instead, the universe has something else built into it: expansion. Space itself is expanding. Galaxies that are not strongly bound together by gravity tend to recede from each other over time. Not because they are all flying away through pre-existing space like debris in an explosion, but because the space between them is stretching. This is one of the hardest ideas to hold comfortably, because it does not behave like ordinary motion. It is not simply that galaxies move through the universe. The universe itself grows between them. And this expansion matters enormously for emptiness. Gravity gathers. Expansion separates. Those two realities are in constant conversation. On small enough scales, gravity wins. Planets stay with stars. Stars stay in galaxies. Galaxies in small groups can remain bound. But on larger scales, especially where structures are not tightly held together, expansion increasingly dominates. It stretches the great gaps. It helps preserve and enlarge the spaces between major structures. So intergalactic emptiness is not just a leftover gap from ancient clustering. It is also something the expanding universe continues to emphasize. This is part of why the cosmos does not look like one giant continuous luminous cloud. Gravity did gather matter, but not everywhere. And expansion kept widening the separations between the great gatherings that did form. It is a little like bread rising in an oven with raisins inside. As the dough expands, the raisins move farther apart, even though they are not actively pushing themselves away from one another. The space between them grows because the medium itself grows. The analogy is imperfect, like all analogies in cosmology, but it offers a soft way into the idea. Galaxies are not simply distant because they started distant. They are also distant because the space between large structures has continued to stretch. And in the modern universe, there is an even more unsettling ingredient involved in that stretching: dark energy. Dark energy is the name we give to the mysterious effect causing the expansion of the universe to accelerate. Not merely continue, but accelerate. Galaxies that are not gravitationally bound to us are, in general, receding, and over very large scales the expansion grows more significant. This means the emptiness between structures is not static. It is not a fixed amount of dark once and for all. In the largest sense, the emptiness is growing. That thought deserves a quiet pause. The spaces between galaxies are not only vast, they are becoming vaster. And perhaps this is why intergalactic emptiness feels so profound. It is not just a passive feature of the universe. It is part of an ongoing trend. Matter gathers locally. Space expands globally. Islands form, while oceans widen. Still, even with gravity and expansion working together to create contrast, another question lingers. Why does the universe feel so uneven to us in the first place? Why do the galaxies seem like scattered lights rather than a connected swarm? Part of the answer lies in how sensitive the human mind is to visible markers. We notice what shines. We anchor ourselves to light. A galaxy, full of stars, becomes easy to imagine as something substantial. The dark between galaxies becomes hard to imagine because it offers almost no visual information. The universe may contain faint gas, plasma, magnetic fields, particles, and invisible dark matter in those regions, but our minds do not emotionally register those the way we register a spiral galaxy glowing against blackness. So the contrast may feel even stronger than it physically is, simply because visible light dominates our intuition. The darkness between galaxies is not always a perfect absence, but it is very often a visual absence. And visual absence is powerful. It turns scale into loneliness. The same effect happens in small ways on Earth. A desert at night may contain air, heat, dust, insects, distant terrain, and subtle sound, but if there are no lights, it still feels empty. The senses collapse the richness of unseen things into one dominant impression: vastness. In the universe, this effect becomes overwhelming. Intergalactic regions may contain traces of matter, but without bright local structure, the dominant experience becomes blackness. There is also another gentle truth here. Galaxies are unusual. Or rather, they are special outcomes, not default conditions. A galaxy is what happens when enough matter gathers in one place, under the right circumstances, over long stretches of time, and begins forming stars. That is already a kind of achievement of cosmic organization. It is not the baseline state of space. The baseline state, if such a thing can be said, is more diffuse, more open, less structured. Galaxies are islands of successful gathering. Intergalactic space is what the broader universe looks like when that gathering has not happened strongly enough in a given region. So the question could be turned around. Instead of asking why the space between galaxies is so empty, we might ask why galaxies are so full. And the answer would be the same set of forces seen from the other side. Tiny unevenness in the early universe. Gravity amplifying those unevenness. Dark matter creating a hidden framework. Ordinary matter falling inward. Stars forming. Light igniting. Structure deepening. Local triumphs of accumulation inside a much more diffuse cosmos. That reversal helps, because it reminds us that emptiness is not the strange exception. It may be closer to the rule. The bright structures feel central to us because we live inside one. Naturally, we think from the inside outward. We begin in a galaxy, under stars, on a planet made of heavy elements forged by older stars. Our entire emotional life has unfolded inside one of the richest local environments the universe produces. From that perspective, emptiness feels surprising. But from the larger perspective, perhaps it is the opposite. Richness is concentrated. Light is concentrated. Complexity is concentrated. Vast openness is what surrounds it all. This is one reason astronomy can feel strangely humbling. It reminds us that our sense of what is normal depends heavily on where we happen to be standing. To creatures born in a galaxy, galaxies feel natural and emptiness feels odd. To the universe as a whole, emptiness may be the larger fact. And even then, emptiness comes in degrees. The space between stars inside a galaxy is already mostly empty, as we have said before. The space between galaxies is emptier. And in the largest cosmic voids, the emptiness becomes more extreme still. What changes is not simply the presence or absence of matter, but how strongly matter has been gathered by gravity relative to the wider expansion of space. That means emptiness is a kind of gradient, not a switch. The universe shades from dense to sparse, from structured to diffuse, from bright to almost bare. We keep looking for hard borders because human beings love categories. But the cosmos prefers transitions. A galaxy fades outward. Its halo thins. The intergalactic medium stretches beyond. Larger structures emerge faintly at enormous scales. And in the deepest voids, even those structures become remote. That gradual thinning is part of what makes the subject so calm, in a way. The universe is not made of harsh on and off states. It is made of long dissolves. What I find most beautiful is that this emptiness is not meaningless. It is not simply wasted room. The large-scale contrast between dense and sparse regions is how the universe organizes itself. The dark spaces help define the bright ones. The bright ones reveal the dark spaces by comparison. And the whole pattern, when viewed from far enough away, begins to resemble something larger than isolated galaxies. Something connected. We are not fully there yet, but you can feel it approaching. Because if galaxies are not distributed randomly, and if matter gathered along hidden gravitational patterns, then maybe the universe is not just a collection of separate islands after all. Maybe the emptiness itself has shape. Maybe the places where galaxies form are part of a larger framework, while the emptiness occupies the spaces around that framework. That is where the story begins to widen. Up to now, emptiness may have seemed like a gap between objects. But soon it will become something stranger and grander than that. It will become the negative space of an enormous cosmic pattern. Before we go there, though, it is worth resting for one more moment in the simple answer. Why does intergalactic space look so empty? Because the early universe was only almost smooth, not perfectly smooth. Because tiny differences in density gave gravity something to work with. Because gravity gathered matter into certain regions and left others behind. Because dark matter helped shape the invisible scaffold of large-scale structure. Because ordinary matter fell into those gravitational wells and formed galaxies. Because expansion stretched the spaces between great structures. Because dark energy now helps those spaces grow larger still. And because human eyes notice brightness more easily than faint matter, making the contrast feel even deeper. In other words, intergalactic space looks so empty because the universe builds by gathering. It makes islands. And whenever islands form, seas appear around them. If these slow explorations help you unwind and drift more peacefully into sleep, you can gently support the channel with a like. And if you want more calm journeys through space, time, and the deeper structure of reality, you're always welcome to subscribe. If you feel like leaving a quiet comment, I always enjoy hearing where you're listening from tonight. For now, just imagine the universe not as a random scattering of lights, but as a patient act of sorting. Matter slowly finding matter. Gravity doing its quiet work. Darkness widening where gathering does not happen. And over billions of years, the cosmos teaching itself to become uneven. Galaxies glow where the gathering succeeded. Intergalactic space opens where it did not. And if that is true, then the next question becomes almost irresistible. What does that larger pattern actually look like? If matter gathered along certain pathways and left other regions astonishingly bare, then perhaps the universe has a shape on the grandest scales. Not the shape of a simple sphere or disk, but the shape of a web. That is where we go next. Part 8, The Cosmic Web and the Giant Voids. If you could travel far enough away from the Milky Way, far enough that our galaxy became only one small light among many, the universe would begin to change shape in your mind. From here, from Earth, the cosmos often feels scattered. A star over there, a galaxy over there, darkness everywhere else. It is easy to imagine the universe as a kind of random arrangement, a glittering spray of lights thrown into blackness without much larger order. And for a long time, that was close to how the universe looked to us. Beautiful, mysterious, and mostly disconnected. But when astronomers began mapping galaxies across truly enormous distances, a different picture emerged. A stranger one. A calmer one, in some ways, and a far more haunting one in others. The galaxies were not scattered randomly at all. They were arranged. Not in neat rows or circles. Not in anything simple enough to fit into ordinary geometry. But in something like strands, filaments, knots, and sheets, with enormous dark cavities opening between them. The universe, seen on the largest scales, did not resemble a uniform mist of galaxies. It resembled a web. And once you see that idea, even just in the imagination, it becomes hard to forget. Because suddenly galaxies are no longer just islands in darkness. They are beads along invisible threads. The emptiness is no longer merely the gap between one object and another. It becomes the vast open chambers inside a much larger structure. Great cosmic hollows. Rooms of near nothing between the luminous scaffolding of everything else. This is what we call the cosmic web. And tonight, we are going to enter it slowly. Not with equations, not with complicated diagrams, but with the quiet feeling of scale. We are going to ask what the cosmic web really is, why it matters, and what it means that some of the largest features in the entire universe are not galaxies or clusters, but voids. Regions so immense and so empty that they make the already enormous gaps between galaxies feel almost crowded by comparison. This is where the story becomes bigger than any single galaxy. Up to now, we have been moving outward in steps. First the galaxy. Then the space between galaxies. Then the reasons that space became so empty. And now we reach the point where all of those local truths join a larger pattern. A pattern so large that the Milky Way, Andromeda, and even whole galaxy clusters begin to look like details inside something wider. The easiest way to imagine the cosmic web is to start with a very human instinct. When we see enough small things gathered together, we want to know whether they form a pattern. A few houses become a street. A few streets become a town. A few towns connected by roads become a region. The mind is always searching for structure beyond the individual object. The universe rewards that instinct. Galaxies do not only form isolated systems. They gather into groups. Groups gather into clusters. Clusters connect through larger filaments of matter. And when we step far enough back, these filaments stretch across unimaginable distances, crossing and branching like a great three-dimensional network. At the intersections, where matter has gathered more strongly, the universe forms dense knots, galaxy clusters containing hundreds or even thousands of galaxies. Along the connecting strands lie smaller groups and streams of galaxies. And between all of that, opening like vast black chambers in the architecture, are the giant voids. This is why the word web is so useful. It is not a perfect analogy, of course. Nothing truly is, once we reach cosmic scale. But it helps because a web has both thread and gap, pattern and emptiness, connection and open space. And that is exactly what the large universe seems to be made of. The bright things do not fill space evenly. They trace a framework. And the voids are what remain between the traces. If you could somehow see this from unimaginably far away, the universe would not look like one glowing ball of stars. It would look almost delicate. Long, faint structures stretching across darkness. Dense intersections where matter collected. Huge regions where very little gathered at all. The result is both beautiful and slightly unsettling, because it tells us something that the night sky hides from us. The universe is not merely large. It is structured by emptiness. That phrase matters. We are used to thinking of structure as the arrangement of things. But in the cosmic web, the empty parts are just as important as the luminous ones. The voids help define the filaments. The filaments help outline the voids. The pattern only exists because both are there together. And these voids are not small. That is where the imagination starts to tremble. Inside a galaxy, the distances are enormous. Between galaxies, the distances become greater still. But the giant voids of the cosmic web can stretch across tens of millions, hundreds of millions, and in some cases perhaps even more than a billion light-years depending on how one defines and measures them. These are regions where galaxies are unusually sparse, sometimes astonishingly sparse, compared with the more populated filaments and clusters around them. It is one thing to say the space between the Milky Way and Andromeda is vast. It is. But the giant voids go beyond that kind of neighborhood scale. They are not just the dark water between two islands. They are more like entire black seas in which islands are unusually absent. And perhaps the most astonishing part is that these voids occupy a tremendous fraction of the universe's volume. Not most of the matter, because matter prefers the filaments and clusters, but most of the room. The larger geometry of the cosmos is, in that sense, dominated by places where very little is happening. The visible richness of the universe lives along the scaffolding. The empty volume fills the rest. This is a deeply humbling idea. Because when we think of the universe, we instinctively think of the places where the drama is. Galaxies, nebulae, black holes, supernovae, bright centers and glowing clouds. But those are, in a very real sense, the highlights, the concentrated scenes. The actual stage on which they sit is much larger, and much quieter. The cosmic web teaches us that the universe is not mostly made of luminous destinations. It is mostly made of the vast intervals between them. One of the most famous examples of a giant void is the Boötes void, sometimes dramatically nicknamed the Great Nothing. It lies hundreds of millions of light-years away and stretches across a region so large that the mind almost stops cooperating when you hear the number. Roughly speaking, it spans on the order of a few 100 million light-years. In a volume that immense, astronomers once expected far more galaxies than were actually found. Instead, the region turned out to be remarkably sparse. There are galaxies inside it, yes. A void is not always perfectly empty. That is important to remember. A cosmic void is a region with far fewer galaxies than average, not necessarily an absolute mathematical zero. But when the scale becomes large enough, sparse begins to feel almost indistinguishable from absent. A few galaxies adrift inside a region hundreds of millions of light-years wide do not make it feel populated. They only make the emptiness feel even stranger. The Boötes void is powerful not just because of its size, but because it gives the imagination a place to stand. It turns the abstract idea of emptiness into a region with dimensions, a true feature of the universe. Not a metaphor, not a feeling, but an actual cosmic environment where matter gathered so weakly that the surrounding darkness became one of the most important facts about it. And there are other vast underdense regions as well, some discussed in terms of local supervoids and broader low-density structures that may affect how we understand our cosmic neighborhood. The details can become technical quickly, and astronomers still refine the map and argue about boundaries, names, and interpretations. But the larger lesson remains steady. The universe contains enormous underfilled regions, and those regions are not side nodes. They are part of the main architecture. This is where scale starts to become almost philosophical. Because a void is not just a bigger empty place. It changes what emptiness means. When you hear that intergalactic space is sparse, you might still imagine one galaxy here and another there, with a long dark crossing in between. But a giant void asks you to step back another level. Imagine not simply one gap between neighboring galaxies, but a great region in which even galaxies themselves are unusually rare. The emptiness has become the defining feature of an entire cosmic landscape. If a galaxy is a city and a galaxy cluster is a metropolitan region, then a giant void is not the road between cities. It is the desert between civilizations. And yet even desert is too rich a word. A desert on Earth still has air, dunes, temperature shifts, rocks, wind, insects, maybe distant life. A cosmic void strips things down far more drastically. It is not barren by terrestrial standards. It is barren by universal standards. So how did these voids form? In spirit, the answer is the same as the one we explored earlier, but now on a larger canvas. The early universe began with tiny variations in density. Matter slowly flowed toward the denser regions, deepening them. As those denser regions grew stronger through gravity, the regions that started out slightly emptier lost more and more of their matter to the surroundings. Over billions of years, those underdense regions expanded into the giant voids we now observe. In other words, voids are not carved out by some cosmic eraser. They are what happens when matter drains away toward the stronger structures nearby. That makes voids feel strangely dynamic. They seem like places of nothing, but they are the result of movement, of matter leaving, of gravity slowly favoring certain regions over others, of the universe separating itself into concentrations and absences. And expansion strengthens this feeling. Because as the universe expands, the contrast between the denser structures and the emptier regions can become even more pronounced. Filaments hold onto their galaxies and dark matter more effectively. Voids, already underfilled, stretch wider. The emptiest places become the places where the expansion of space feels most unconstrained by local gravitational gathering. This gives the cosmic web a subtle sense of living change, even though those changes occur over timescales far beyond human life. The web is not frozen like a decorative pattern. It evolves. Filaments grow. Clusters merge. Matter shifts. Voids widen. The universe keeps redistributing itself, slowly and quietly, with emptiness becoming an ever more visible part of the picture. There is also something emotionally remarkable about the web itself. It is not a structure we can see directly with our eyes in the night sky. The sky is too local, too limited by perspective. We live inside one galaxy, and from inside it the larger architecture is hidden. To discover the web, humanity had to become patient and indirect. We had to map galaxies across great distances. We had to measure redshifts, positions, clusters, and distributions. We had to let the pattern reveal itself piece by piece. That means the cosmic web is one of those truths the universe does not simply hand over. It has to be inferred, reconstructed, seen with the mind before it can be pictured. I find that beautiful. It means the largest structure we know is not something obvious and dramatic in the sky above us. It is something that emerges only when enough fragments are joined. A hidden order inside apparent scattering. A proof that reality often becomes more coherent, not less, the farther we pull back. And there is one more layer to this. The cosmic web is not made only of the galaxies we can see. In fact, much of its underlying mass is dark matter, invisible and known only through gravitational effects. The galaxies are, in a way, the lanterns hung along the framework. They let us trace where the deeper structure lies. But they are not the whole thing. Beneath the visible pattern is a much larger invisible architecture, shaped by matter we still do not fully understand. That thought can be wonderfully unsettling in a sleep-friendly way. Even the web of the universe, as grand as it is only partially lit. We are seeing the glowing hints of a deeper design. And the voids, too, are not necessarily pure nothingness. They may still contain very thin gas, faint dark matter distributions, and the occasional isolated galaxy or small structure. But relative to the surrounding cosmic average, they remain astonishingly empty. Empty enough that if you somehow lived inside a deep void, your picture of the universe might be profoundly different. The nearest galaxies would be farther away. The sky would feel more isolated. The discovery of the broader cosmos might take much longer. Your local environment would teach you a lonelier version of reality. That is a strange and moving thought. Our understanding of the universe depends, in part, on where we stand inside it. If the Milky Way had formed in a much emptier region, the story humanity told itself about the cosmos might have been delayed or altered. We learn the universe by the company it gives us, and the company of galaxies matters. This is one reason giant voids feel so psychologically powerful. They are not just big spaces. They are alternate contexts. Places where the universe presents itself differently. And yet even from our more populated location, the lesson of the web still reaches us. It tells us that we do not live in a universe of evenly shared abundance. We live in a universe of threads and hollows, of rich intersections and silent cavities, of matter gathered into luminous pathways while most of the volume remains sparse and dark. That realization can sound bleak at first, but it is not necessarily bleak at all. In another sense, it makes the universe more legible, more dramatic, more precious. If galaxies were everywhere in equal measure, the sky might lose some of its mystery. Structure needs contrast. A web is beautiful because of both the silk and the open air between the silk. The same is true of the cosmos. The filaments glow more meaningfully because the voids around them are so large. The knots of galaxies feel more astonishing because they stand against so much emptiness. The universe is not stingy with matter. It is selective with concentration. And that selectivity is what creates the cosmic web. If these slow journeys through science and the larger universe help you unwind, you can gently support the channel with a like. And if you'd like more calm explorations like this, you're always welcome to subscribe. If you feel like it, leave a comment and tell me where in the world you're listening from tonight. For now, though, just imagine drifting outward once more. Past the Milky Way. Past Andromeda. Past the local gathering of nearby galaxies. Far enough that even clusters become only bright knots in the dark. Now the larger shape appears. Long, faint strands of galaxies stretching across vast distances. Dense intersections where those strands meet. And between them, giant hollows opening like silent chambers in the architecture of the universe. The cosmos is no longer a scattered field of lights. It is a web, and most of its room belongs to the voids. Once that settles in, another question begins to rise naturally. If the universe is arranged this way, with galaxies tracing a vast web through darkness, then where are we inside that structure? Are we in a crowded knot, on a quiet filament, near the edge of some great emptiness, or already deeper inside one than we realize? That is where we go next. Part 9, what it would feel like to travel through intergalactic space. By now, the scale of intergalactic space has become something more than a number. It began as a question. How big is the space between galaxies, really? Then it widened. A galaxy became a place instead of a word. Intergalactic space became an environment instead of a blank. Distances stretched from light years to millions of light years. Nearby galaxies became remote neighbors. The cosmic web appeared. The giant voids opened. And somewhere along the way, the emptiness stopped feeling like a side detail and became the main character of the story. But there is still one way to understand it that numbers alone cannot quite give us. We can imagine being there. Not just measuring it, but inhabiting it, at least in the mind. Drifting through it slowly enough to feel its character. Leaving behind the comfort of a galaxy and entering the deep black between structures. Because sometimes the best way to understand scale is not to calculate it, but to ask a more human question. What would it actually feel like to travel through intergalactic space? Not in a dramatic science fiction way. Not with battles, alarms, impossible engines, or windows full of dazzling objects every few seconds. The truth is almost the opposite of that. If you could really travel through intergalactic space, the most striking thing would not be action. It would be the absence of action, the quiet, the patience, the almost unbearable lack of nearby reference points. It would not feel like flying through a busy universe. It would feel like entering the part of reality that was never made for human senses. And perhaps that is why it can feel so strangely calming to imagine. Because intergalactic space is not aggressive. It is not noisy. It does not rush toward you. It barely seems to acknowledge you at all. It is the universe in one of its most stripped-down moods. A place where almost everything we rely on to feel oriented, grounded, and connected begins to fade away. Let us begin the journey gently. Imagine you are leaving the Milky Way. At first, the galaxy is still all around you. Not as a grand spiral seen from above, because from within it the structure is harder to feel, but as a rich field of stars, faint clouds, dark lanes, and the general sense that you are still inside a vast home. Even in deep space beyond the planets, a galaxy still gives you a background. There are stars in every direction. There is texture to the sky. There are regions more crowded and less crowded. There is a subtle brightness through the galactic plane. You still belong to a visible environment. But then, slowly, that begins to change. As you move farther away from the Milky Way's disk, the familiar band of starlight narrows. The once rich spread of stars becomes less balanced. The galaxy starts to gather itself into one direction behind you, becoming not an all-encompassing sky, but an object, a structure, a great luminous continent in the dark. At first it is still overwhelming, but now it has edges, or something like edges. You are no longer simply inside it. You are watching it recede. This may be the first emotional turning point of the journey. Because the moment a galaxy becomes an object instead of an environment, the mind loses one of its oldest cosmic comforts. The sky is no longer full in the way it used to be. Home begins to pull itself together into a distant shape, and the surrounding darkness starts to matter more. Keep going. The Milky Way shrinks further. What once felt like the whole visible stage of existence is now a brilliant but bounded form behind you. Spiral structure may still be hard to resolve depending on your distance, but its general character is clear. A bright center, sweeping arms, a wide disk, clouds of stars, a halo fading into blackness. You can finally see your home as it always was, one galaxy among others. And ahead of you? Almost nothing nearby. That is the next thing that would strike you. There would be no steady parade of objects to pass. No asteroid fields every few minutes. No dense traffic of stars. No local scenery. Intergalactic travel would not feel like crossing a crowded harbor. It would feel like leaving one island behind and entering an ocean so vast that, for long stretches, the word ocean itself would seem too busy. This is hard for the imagination because movies have taught us the wrong instincts. They fill space with motion and events because the human eye gets restless. But the real intergalactic dark would be almost offensively patient. You could drift for unimaginable spans of time without anything changing in a way a human nervous system would call meaningful. The surrounding view would be largely stable. The nearest great structures would remain remote. The emptiness would not unfold dramatically. It would simply continue. That may be the deepest psychological challenge of such a journey. Human beings understand progress by landmarks. A road bends. A mountain grows closer. A coastline changes shape. A city appears on the horizon. Even at sea, there is weather, light, and the movement of water. But in intergalactic space, the journey would often lack the ordinary signs of movement. If your instruments were turned off and you had only your senses, you might not even feel that you were going anywhere at all. This is because space itself does not produce the sensation of motion. We feel motion through change, through wind on skin, pressure in the body, scenery sliding past, acceleration, vibration, sound. Remove those things, and movement becomes abstract. In intergalactic space, unless your craft were accelerating or vibrating in some obvious way, the universe outside might remain so unchanged for so long that stillness would feel like the dominant truth, even while you crossed impossible distances. And that stillness would have a certain kind of silence. Now, of course, space is silent in the ordinary sense because sound needs a medium like air or water to travel. Intergalactic space, being so thin, offers almost none of that. So if you were inside a spacecraft, whatever you heard would come mostly from the ship itself. The hum of systems, a quiet vibration, perhaps the circulation of air, the tiny domestic sounds of a machine carrying warmth through a place that has none. Outside, the universe would not roar or whisper. It would not make a sound at all. That silence matters more than it may seem. On Earth, silence is never truly silence. There is always some background, air moving, distant traffic, insects, water, building sounds, the body itself. But intergalactic silence, or at least the idea of it, carries a different emotional quality. It is not just the absence of noise. It is the absence of nearby events, the absence of local life, the absence of a world pressing in on you from all sides. And yet the darkness would not be a perfect visual blank. That is another important point. Even in intergalactic space, you would still see galaxies. The Milky Way behind you, shrinking slowly. Andromeda, perhaps, or other galaxies in your broader region depending on where you traveled. But these would not usually dominate the whole sky. They would be distant structures, bright by comparison with the black around them, but still remote enough to feel unreachable. You would also see stars, but far fewer nearby stars than if you remained inside a galaxy. The local abundance of stellar points that makes the sky feel inhabited would drop away. The sky would become less like a field of lights and more like a deep chamber containing a few great, distant lanterns. That reduction would change the emotional character of the heavens completely. From Earth, even under dark skies, the stars give the illusion of company. Thousands of points, a dense visual texture, a kind of cosmic companionship. In deep intergalactic space, much of that would vanish. The nearest stars belonging to your own home galaxy would be falling behind. The stars of other galaxies would be blended into distant glows, not nearby individuals. The sky would become less intimate and more architectural. Less like a place full of neighbors, more like a place defined by remote structures and enormous gaps. If you entered one of the larger voids, the effect would deepen. Now imagine not just crossing the space between two major galaxies in a relatively connected region, but moving through a true cosmic void, one of the giant underdense hollows of the cosmic web. In such a place, the nearest significant structures would be farther still. The galaxies would appear more isolated from one another. The dark between them would be even more dominant. The sense of orientation would become more abstract. You would no longer feel like a traveler between cities. You would feel like a traveler in a desert so broad that the nearest settlement lay beyond any meaningful horizon. And yet even desert is too generous. Because deserts still have ground. They still offer a direction called down. They still give you weather and texture and local detail. Intergalactic space gives almost none of that. No horizon. No ground. No sky in the old sense. No up. No down. Only perspective anchored by whatever your ship chooses to call forward, back, left, and right. This may be one of the strangest psychological effects of all. Human orientation is not just visual. It is bodily. We know where we are because gravity gives us vertical meaning. Feet downward, head upward. On a planet, that framework is so constant that we hardly notice it. In intergalactic space, without a nearby world, vertical becomes local and arbitrary. Your spacecraft defines it for you. If the craft rolled slowly, up and down would roll with it. Outside, the universe would not care. The galaxies would remain where they are. The darkness would remain where it is. Direction would become a private agreement inside your own vessel. That can feel unsettling, but also strangely freeing. Because once there is no cosmic up or down, the universe stops behaving like a stage and begins behaving like a volume. You are not under the stars or above them. You are among vast relationships of distance, suspended in a structure that does not privilege your orientation at all. The passage of time would change, too. Not physically in the dramatic science fiction sense, unless your speed approached extremes where relativity became an important part of your journey. But psychologically, time would alter its character. Days and nights would become artificial if you were not near a star. Circadian rhythm, that deep biological pattern shaped by sunrise and sunset, would need to be maintained by choice or machinery. Without a nearby sun rising and falling, time would lose one of its oldest natural markers. It would become something measured by clocks and routines, not by the sky. This is easy to underestimate. Much of human calm depends on cycles. Morning light, evening dimness, the passage of shadows, weather, the slow change of a familiar world. These things tell the body where it is in time. Intergalactic travel would remove them, and in their absence, time might begin to feel both flatter and stranger. A week could pass in routine and still feel detached from natural sequence. Months might accumulate with very little external change. A year could go by with the same black beyond the window and the same distant smudges of light not seeming much closer at all. That is another way intergalactic space humbles the mind. It weakens our ordinary partnership with time. On Earth, time is visible. Seasons change. Trees change. Skies change. In intergalactic space, time becomes more internal. The body changes. The ship changes. Instruments record change. But the outside universe may look almost patient beyond belief. At human scales, the great structures of the cosmos are mostly still. If you traveled for thousands of years, then perhaps the sky would begin to rearrange in ways that felt undeniable. Galaxies would shift. Home would recede into a smaller and smaller patch. Your destination would gradually expand, but no single human life would ever naturally experience such a crossing with current technology. That is part of the point. The scale is not merely difficult. It is fundamentally hostile to the ordinary tempo of mortal existence. And that is perhaps the most haunting truth in this whole section. Intergalactic space is not just empty in the physical sense. It is empty in the narrative sense. It resists story. It resists progress at human speeds. It resists the compact, satisfying arc that most journeys have. You do not set out in the morning and arrive by sunset. You do not even set out in youth and arrive in old age. The crossing is so large that it almost rejects the human idea of travel altogether. Yet for that very reason, it becomes a powerful place for imagination. Because once you accept that there would be no hurry there, the experience changes. It becomes less about arrival and more about exposure. Exposure to scale. Exposure to stillness. Exposure to a universe that does not organize itself around our lives. You would not cross intergalactic space the way you cross a country. You would inhabit an interval. A long, patient interval in which the main event is the existence of the interval itself. And perhaps that is why imagining such a journey can feel strangely good before sleep. It simplifies things. No emails. No deadlines. No traffic. No noise from the world. No crowded horizon of tasks. Just the ship, the dark, the faint light of impossible distances, and the slow understanding that reality is far larger and quieter than the nervous mind usually remembers. Intergalactic space would reduce life to essentials very quickly. Warmth, air, rhythm, rest, observation, maintenance, memory, hope, perhaps, but not the cluttered hope of daily life. A quieter one. The hope of direction in a place with almost no landmarks. There is something almost monastic about that. A long journey through intergalactic darkness would force the mind into an intimacy with scale. At first, that might feel lonely. Deeply lonely. The kind of loneliness that comes not from being unloved, but from being small. But after a while, perhaps, the loneliness would soften into perspective. The ship would become a tiny island of human order moving through a vast ocean of cosmic indifference. And somehow that contrast might make every small thing inside the ship feel more precious. A warm light, a voice, a hand on a surface, a cup of water, a remembered song, a photograph of Earth. That is one of the secret gifts of vastness. It makes small things glow. And Earth, seen from such a journey, would glow most of all. Because once you leave a galaxy, or even begin to imagine leaving it, home changes meaning. Home is no longer just a planet under your feet. It is no longer even just a solar system. It is a chain of belonging. Earth inside the solar system. The solar system inside the Milky Way. The Milky Way inside a local galactic gathering. That whole chain becomes visible only when you risk losing it in the imagination. Intergalactic space does not make home irrelevant. It makes home legible. You would understand, perhaps more clearly than ever before, that nearly everything human has happened in one tiny protected corner of one galaxy among countless others. All our languages, songs, fears, wars, loves, children, books, illnesses, discoveries, prayers, memories, and quiet evenings have unfolded in one extremely local shelter of light. And around that shelter lies an almost incomprehensible amount of dark. Not hostile dark. Not evil dark. Just deep, indifferent, spacious dark. The kind that does not oppose life but also does not help explain it. The kind that makes life seem improbable and therefore precious. There would be beauty in the journey too, though not always the flashy kind people expect. The beauty would come from the purity of the scene. A distant galaxy turning slowly into a larger shape over ages. Another falling away behind you. The black between them so complete that even faint glows acquire significance. The sheer simplicity of the composition. Light here, darkness there, vastness everywhere. And sometimes, maybe, the beauty would come from knowledge more than sight. Knowing that the space around you, though thin beyond belief, still contains traces of hydrogen, faint radiation, invisible fields, old particles crossing ancient paths. Knowing that even here the universe never becomes perfect nothing. Knowing that your ship passes through the quiet leftovers of cosmic history. That knowledge would make the emptiness feel less dead and more austere. Less barren and more minimal. If these calm explorations help you unwind and fall asleep a little more gently, you can quietly support the channel with a like. And if you'd like more slow journeys through science, space, and the deeper structure of reality, you're always welcome to subscribe. If you feel like leaving a comment, I always enjoy hearing where in the world you're listening from tonight. For now, though, stay with the image. A small craft moving through intergalactic dark. Behind you, the Milky Way, no longer a sky but a distant island of light. Ahead of you, another galaxy, still so far away that it changes almost too slowly to perceive. Around you, no horizon, no wind, no sound, no up or down, only the long stillness of space between great structures. Inside the craft, a pocket of warmth and time and memory. Outside it, the patient architecture of the universe, stretched across distances so large that even light must spend millions of years crossing them. That is what it would feel like to travel through intergalactic space. Not like an adventure in the ordinary sense. More like entering a level of reality so quiet, so stripped of landmarks, that the mind has no choice but to become still with it. And once you have imagined that stillness, one final question remains. After all the distances, all the emptiness, all the galaxies and voids and dark between them, how big is intergalactic space really when we step back one last time and try to hold the whole picture together? That is where we go next. Part 10. So how big is intergalactic space, really? Now that we have traveled this far, through galaxies, through the thin medium between them, through the great dark filaments and voids of the cosmic web, we can return to the original question one last time. How big is intergalactic space, really? At the beginning, it sounded almost simple, like something that might have one clean number attached to it, a fact to memorize, a neat answer to place in the mind and carry away. But by now, you can probably feel why the question does not behave that way. Intergalactic space is not one fixed gap. It is not one measurable hallway between two obvious walls. It is not even the same kind of emptiness everywhere. It changes with scale. It changes with location. It changes depending on whether you are speaking about neighboring galaxies, larger groups, filaments, clusters, or the giant voids between them. And maybe that is the most honest place to begin the answer. Intergalactic space is not one size. It is a whole family of distances, a whole geography of separations, a whole architecture of dark intervals between the places where matter gathered. The smallest version of it, if we can even call it small, is the space between nearby galaxies in the same local region. The Milky Way and Andromeda, for example, are separated by about 2.5 million light-years. That alone is enough to overwhelm ordinary intuition. 2.5 million years for light itself to cross from one great galaxy to the other. A gulf so broad that the whole of recorded human history disappears inside it like a speck. And yet that is only the local version of the story. Because galaxies also gather into groups, clusters, and filaments. The spaces between these larger structures become greater still. Tens of millions of light years. Hundreds of millions. In the giant voids of the cosmic web, the emptiness expands into regions so vast that even galaxies themselves become sparse. The dark is no longer just what lies between neighboring islands. It becomes the dominant landscape. So when we ask how big intergalactic space really is, the most truthful answer is this. It begins at millions of light years. And then, in the larger structure of the universe, it opens outward into tens or hundreds of millions more. That is already the scientific answer in spirit. But perhaps it is not yet the emotional answer. And with a subject like this, the emotional answer matters just as much. Because numbers alone do not change perspective. They only decorate it. The true scale lands only when the mind begins to feel what the numbers are saying. So let us gather the whole picture softly, one last time. A galaxy is already mostly empty. That was one of the first strange lessons. Even inside the Milky Way, where stars feel abundant to us, the distances between stars are immense. A galaxy is not a crowded jewel box. It is a vast gravitational structure in which the luminous things are scattered across tremendous space. The stars belong together as part of one system, but they are far from one another. Even home is mostly dark. Then we stepped farther out. We left behind the comfort of thinking in kilometers. Then even astronomical units became too small. Light years took over. We realized that our own galaxy, the Milky Way, is around 100,000 light years across in its visible form, already a scale almost beyond ordinary feeling. And then the nearest major galaxy, Andromeda, stood before us at a distance roughly 25 times larger than the width of the Milky Way itself. That is the first moment the question begins to reveal its true shape. If one galaxy is already that large, and the next major one is still millions of light years away, then the universe is not built on closeness. It is built on separation. That is the real answer hidden inside the measurements. Intergalactic space is big in the way oceans are big only if the islands are tiny. It is big in the way silence is big only if the notes are rare. It is big because the luminous structures of the universe are scattered, not packed. And the more we widened the view, the clearer that became. We learned that intergalactic space is not perfectly empty, not in the strictest sense. It contains thin gas, mostly hydrogen, traces of heavier elements, radiation, faint magnetic fields, and the leftovers of ancient cosmic history. Sometimes even lonely stars, perhaps worlds, perhaps the faint exiles of older galactic encounters. But all of that remains so sparse that emptiness is still the dominant truth. The space between galaxies is not truly nothing. It is simply so close to nothing that, for the human imagination, the difference barely softens the impact. Then we asked why it is this way at all. Why gather matter into galaxies and leave such enormous stretches between them? And the answer turned out to be slow and beautiful. Tiny Venuses in the early universe. Gravity patiently pulling matter into denser regions. Dark matter shaping the invisible framework. Ordinary matter falling inward. Galaxies igniting along the stronger lines of attraction. And everywhere else, relative depletion. Emptier regions becoming emptier still, because matter had moved away toward the places where structure was forming. The universe, in other words, built itself by gathering. And whenever things gather, something else is left open. That openness is intergalactic space. By the time we reached the cosmic web, the whole subject transformed. The emptiness was no longer merely the gap between objects. It became the negative space of a larger pattern. Galaxies traced filaments, knots, and sheets across the cosmos, while giant voids opened between them like vast black chambers in the architecture of reality itself. This may be the most important shift of all, because once you see the universe as a web, you stop asking only how far one galaxy is from another. You begin asking how the dark itself is arranged. You begin seeing that the cosmos is not a crowded place punctuated by small spaces. It is a spacious place punctuated by concentrated light. That inversion changes everything. From inside a galaxy, light feels normal and emptiness feels surprising. From the larger cosmic view, emptiness may be closer to the rule, and the galaxies are the rare concentrations. In that sense, intergalactic space is not a side detail of the universe. It is the larger setting in which galaxies happen. And perhaps that is why the question feels so haunting. Because in asking how big intergalactic space is, we are really asking something deeper. We are asking how much room the universe gives itself between one meaningful structure and the next. How loosely reality is arranged. How generous the cosmos is with darkness. The answer, as far as we can tell, is extraordinarily generous. So generous, in fact, that even entire galaxies can feel like local exceptions. Small islands of organization inside a much wider expanse of sparse matter and growing separation. And the separation is still growing. That is another part of the answer that deserves to be held quietly. The universe is expanding. On the largest scales, the space between great structures is not fixed forever. It stretches. Galaxies not bound together by gravity recede from one another over cosmic time. Dark energy appears to drive this expansion faster and faster on the largest scales. So intergalactic space is not merely vast. It is becoming vaster. That thought changes the tone of everything. The emptiness is not a static backdrop. It is part of a living trend in the cosmos. The dark between galaxies is widening. If we imagine a far future universe, the picture becomes even more austere. Galaxies beyond our local gravitational neighborhood will drift farther away, more isolated, dimmer. Eventually, from the perspective of unimaginably distant future observers, much of the wider universe may become invisible beyond a cosmic horizon. The great web we can still detect today may no longer be obvious at all. The emptiness will not just remain. It will deepen in practical terms, as more of the universe slips beyond view. That is one of the strangest and calmest facts in cosmology. The cosmos was once denser, more connected, more accessible in light. And over time, the spaces between the great structures become increasingly dominant. So how big is intergalactic space, really? Big enough that our nearest major galactic neighbor is still 2.5 million light-years away. Big enough that whole clusters and filaments of galaxies are separated by tens and hundreds of millions of light-years. Big enough that giant voids can span regions so enormous that the mind almost gives up trying to picture them. Big enough that the dark is not the exception around galaxies, but the prevailing condition around which galaxies are arranged. That is the measurable answer. But there is another answer, one less numerical and perhaps more human. Intergalactic space is big enough to change what far means. That may be the most useful way to say it. On Earth, far means effort, a long drive, a long flight, a journey across a sea. On the scale of stars, far means years for light. On the scale of galaxies, far becomes so large that it no longer belongs to human travel at all. It belongs to epochs, to the age of species, to the long unfolding of cosmic history. Intergalactic distance does not merely challenge our vehicles. It challenges our categories. It forces us to stop thinking like travelers and start thinking like witnesses. We are not built to cross those gulfs. Not with our current lives, our current bodies, our current timescales. We are built to stand briefly in one small corner of one galaxy and notice, with a mixture of awe and humility, how enormous the rest is. Perhaps that is enough. Perhaps understanding is its own form of travel. And understanding this particular scale does something subtle to the mind. It makes Earth feel smaller, yes, but also dearer. It makes human concerns feel modest, but not meaningless. It makes the familiar world glow more brightly against the larger dark. That is one of the gifts of cosmic perspective when it is approached calmly. It does not only shrink us, it clarifies us. When you realize that galaxies are scattered across vast emptiness, and that the life of our species has unfolded on one tiny world inside one of those galaxies, ordinary things begin to feel more improbable and therefore more precious. Breath, water, warmth, memory, laughter, sleep, a voice in the next room, the weight of a blanket, the simple fact of being somewhere instead of nowhere. The universe is lavish with distance, but very selective with sanctuary. And Earth is part of one such sanctuary. This is why the subject never feels purely cold to me. Yes, the scales are intimidating. Yes, the emptiness is almost beyond emotional reach. But the more room the universe leaves between its great structures, the more astonishing it feels that there are places where light gathered, where chemistry deepened, where stars formed heavy elements, where planets cooled, where life could emerge, where consciousness could wake up and ask questions like this one at all. Intergalactic space makes those rare conditions stand out. If the universe were uniformly crowded, perhaps galaxies would feel ordinary. But against such profound emptiness, every galaxy becomes a kind of miracle of concentration, and every inhabited world becomes more miraculous still. So perhaps the deepest answer to the question is not merely that intergalactic space is huge. It is that it provides the contrast by which everything luminous becomes visible. The darkness is not just empty room. It is the black velvet against which the jewels of structure are displayed. It is the silence that lets the notes matter, the pause that makes the music intelligible. Without the emptiness, the galaxies would not feel the same. Without the great intervals, light would not feel so improbably gathered. Without intergalactic space, the universe would lose some of the very drama that makes it beautiful. And maybe this is where the whole journey circles back to us. Because human life also happens inside intervals. Between birth and death. Between memory and expectation. Between one season and the next. We spend much of our time focused on the bright points, the events, the milestones, the places where something obvious happens. But perhaps the cosmos offers another lesson. Perhaps the spaces between things also matter. The quiet, the waiting, the long stillness between moments of brightness. Not as absence, but as context. Intergalactic space is the universe reminding us that emptiness is not always a failure of meaning. Sometimes it is what allows meaning to stand out at all. If these calm journeys through science and the cosmos help you unwind at the end of the day, you can gently support the channel with a like. And if you'd like more slow explorations like this, you're always welcome to subscribe. If you feel like leaving a comment before you drift off, I always enjoy hearing where in the world you're listening from tonight. For now, though, let the whole picture settle softly. The Milky Way, one galaxy among many. Andromeda, our nearest major neighbor, still millions of light years away. Groups of galaxies bound together in local company. Clusters and filaments stretching across a larger hidden web. Giant voids opening between them like silent chambers in the architecture of the universe. All of it expanding. All of it growing more separated over time. And somewhere inside that vast design, one small world turning quietly around one ordinary star. Inside one spiral arm of one galaxy, where a conscious mind can lie awake for a while and wonder how large the dark really is. The answer is bigger than a number. It is big enough that the bright parts of the universe are islands. Big enough that even galaxies are local exceptions in a much larger sea. Big enough that light itself needs millions of years just to cross the nearest of the great gulfs. Big enough that the emptiness becomes one of the main facts of reality. And yet, somehow, not so big that it erases us. Because here we are, inside one of the luminous places, asking, listening, imagining, and perhaps that is the quietest miracle of all.